That's a great story. How did it end, Dawn?
We keep trying to be more honest with our science.
And that was a happy ending, yeah?
Hopefully, but we're still we're on that last step now.
It's a good story. It's a good story.
I got a story. I built a gas centrifuge. I spun it around. I haven't really done this, but I have seen them. And they spin it around really fast, and the air forms next to a vacuum. So when there's a force acting on air, it doesn't necessarily equalize.
That is a great story.
I've got another story for that as well.
Another great story.
Imagine a vacuum.
Some fantastic stories today, guys.
Imagine spinning a bucket inside of a vacuum with a bit of gas in there, and and actually operating under the same circumstances. Imagine that. And hold on, you're swinging a container around and trying to prove that gas pressure. You don't need a container to have gas pressure, but then you're actually using the container. You swing it around. I mean, it's pretty funny.
Right. Yeah. Gravity only goes so far.
Container, though, is that? I mean, is that not correct?
It's a container. So you've got gas pressure in a container, but we're asking you to show us gas pressure without a container, and then you're swinging it around, not inside of vacuums. But what do you reckon would happen if you swung it around inside of a vacuum? Obviously, that centrifugal force wouldn't fucking have a chance.
But the entire universe is in a container, though.
Exactly. How'd you have a vacuum without a container? Exactly.
So we stuck an Uber pipe up a unicorn's ass and
so we have two containers.
No,
now.
Brommy, he's a flat earther, I think. Baked beans.
All right, I'm agreeing with him. How'd you have a vacuum without a container?
So I'm going to eliminate the universe as a container because we don't need that one to survive.
How'd you have a vacuum without a container?
Basically, y'all have conceded the entire point to the globe skeptics here because the entire universe is a container, and that's what we've been talking about the whole time, is that we need a container for...
Well, I'd say I don't know.
Right?
I don't know if the universe is contained or not. I don't know. That's the honest answer.
It seems to be expanding continuously, so it doesn't seem like it's...
It does seem to be, but there's no evidence of it at all. It seems that way, but there's no evidence of it at all.
Except for the evidence.
That we're flying like a nightmare towards Polaris. We're eventually going to crash into it because it's dead overhead.
Not towards Polaris. Why would you say that?
You might not want to talk too much baked beans until you understand what you're talking about.
I think I understand it fairly thoroughly.
Moya.
Thank you very much.
That's one of the dumbest things I've ever heard.
Moya, can't you see Curved is talking to the guy? Why would you do that?
Yeah. Curved will yell at me. He doesn't need you to...
Yeah, he doesn't need you over-talking him as well. Go ahead, Curved.
I already made my point. That's one of the dumbest things I've heard all day, what Baked Bean said about us crashing into Polaris. What is... I don't even want to know where he gets it from. Just keep it to yourself, man. You're not helping anything with that shit.
All I said was you guys have conceded the point to the flat earthers that the entire universe is in a container. So whenever we observe pressure, we are looking at pressure inside of a container, are we not?
So I didn't. So for me personally, I didn't concede that point. I don't know if anybody else does.
Yeah, so let those who concede that point foolish answer it, yeah?
If you look at it that way, you've got atmospheres around various planets and such, and then vacuum like in between and all that within that one container that you're just say asserting, not to be argumentative. I don't know what else to call it, but the point you're trying to make is completely irrelevant to what's going on here. We're talking about the separation of our atmosphere from the vacuum surrounding it in the space outside of the atmosphere.
To back that up, if you have to go to our imagination about the edges of the universe to back up your flat Earth sky pressure system, then you've got some problems.
No, we just have to go to.
I'm not.
No, you. I'm agreeing with you.
We're just using 14 psi. We don't need the universe to exist.
I'm just saying.
What I would like to say though, all the people that do understand the argument,
you're
Older people that
using
do understand
our
the argument.
half belief of a edge of a universe to argue you're flat Earth, and you've got issues.
No, he
The
wants
people that do understand the argument, gas pressure without a container, welcome to flat Earth.
He is a flat earther, or he wants to debunk the globe. He's a globe skeptic. That's what he wants to do.
A globe skeptic just says he's not convinced the Earth is a globe. Doesn't mean he's convinced it's flat.
Right, that's what I just said. So he might not be a flat earther, he's just a globe skeptic.
We observe and experience a flat, motionless plane.
Where that's gas pressure without a container. That's held by
it's got a lot to do with gas pressure.
That's plasma being held in place by magnetic fields. So
Conspiracy Cat said it. Conspiracy Cat said himself that you don't even. He said, "I don't need a container. All you need is gas in the first place to have gas pressure without a container." But how do you have a gas gradient inside of a vacuum?
Because if you put gas into a wait 1 second, if you put gas into a vacuum, it's no longer a fucking vacuum and will have gas pressure.
Well, that's the planet. That's the planet. The planet's inside of a vacuum.
Yeah. So therefore,
and it has a gas gradient. So how could you have gas inside of a vacuum? That's the fucking vacuum. Welcome to flat Earth. Welcome to flat Earth.
So how would you have gas pressure? How would you have
it out on your own
without gravity?
Welcome to flat Earth.
Hey, I think we brought a bunch of globers to flat Earth. Welcome, guys.
Yeah. It's like I don't know why we bothered to actually participate in the conversation because he's making everything up for us. So what's the point? So,
you said it yourself. You said how can you have gas inside of a vacuum? So it wouldn't be a vacuum if it was. And now you understand we have gas inside of a vacuum.
Using that as an Rummy. He asked you a question, and you are using it as an admission that there's no conceivable way to do it. He asked you a question. Answer the question. Don't say.
He made a statement. He made a statement saying it wouldn't be a vacuum if it was gas.
Brummy. Can we kind of hear from
anyway,
Bait?
I'm going to go and cook because I've got better things to do, like watching paint dry, than listen to this.
Yeah, I mean, he's run away now. By the way,
let me ask my fellow flat earthers a question.
Wanted to find out why he's skeptical about the globe.
Hey, you can't have a vacuum without a container either.
Sure. You can't have a vacuum.
Can I ask a question, Kimo?
Sorry, yeah, absolutely.
So, as flat earthers, are you willing to accept if they do have a mass attracting mass phenomenon? Would you accept that could hold a pressure system to a planet?
No.
If it did exist, or do you think that even that didn't work, even if it did exist?
If it existed, we would see fog pulling down to the water all the time, and it doesn't. It just sits there.
Okay. So yeah, so we're not even happy with the whole system that you've come up with.
Yeah, but you don't even have that force to even begin with, do you?
Well, that's what I'm saying. I'm asking you if they did, would that work?
Well, let's think about it. If you had gravity,
pseudo-container.
If you had gravity, you would have a ball. You would have your universe. You'd have everything that you say that exists. You see?
Okay. So would you say if we did have gravity, that would work as a pseudo-container, and we wouldn't have this argument?
Yes, because gravity is not a real thing. If it was a real thing, then it would apply to a globe. You see, on a flat Earth, gravity is not needed. It's not necessary.
Okay.
See?
You know what I want to mention. Right, imagine you've got a very, very, very large ball inside of a warehouse, like a very large, I don't know, a large structure, a lot of mass, or whatever you want to, however you want to mention it, and then you dangled like a piece of, like a very, onto fishing wire, you had like a little ball or something on the end of that. Do you ever think that ball would ever be attracted slightly to that large structure inside there? There's no wind affecting it. You know what the Cavendish said? They tried to explain the Cavendish. But if mass was attracting mass, right? Wouldn't you just dangle one piece of string with a ball on the end of it, and then have a very large structure on the other side, and then we should see some sort of attraction that should slightly bend, shouldn't it?
They've done it.
Have they done it, Missy?
Yeah, they've got a large mountain with a pendulum next to it, and they claim.
Where's that?
You'll have to wait till Woz. He's got the link or whatever, but yeah, he seems to think that this huge mountain is pulling the pendulum towards. But obviously, we know that's nonsense because they can't demonstrate that. But yeah, that's the idea. They've got a paper. They love their papers. If it's written down,
what I was trying to get to is we're not arguing the fact that gravity could hold an atmosphere to a planet. We're just arguing that it doesn't exist entirely.
Yeah, there is no gravity. It's not a thing.
Yeah.
It's not a thing. It only exists on a spherical object. If there were spherical objects.
9.8 meters per second.
Huge. What?
And it would have to be a sphere too, because everything pulls equally. You couldn't have some kind of weird shaped rock.
Right.
Let's get this straight. Is it a sphere or is it a sapphire?
Sphere. Spherical.
9.8 meters per second squared.
You don't need that extra vowel in there, Kimo.
So, if the Earth were, if there were gravity, like I say, then yeah, you would have your force. If you have a force, then it would work accordingly. It would act accordingly. It would do all the things that you say it does.
It's just plain dishonest, because I told you 9.8 meters per second squared. That is not a force, that is an acceleration.
Oh yeah, this morning we had a show about that. We've been able to, because it was about great discoveries. So we've discovered we can control that rate. We can make things move quicker, faster, slower, or just stop.
Oh my! You mean by changing the medium?
Yeah, we changed the we changed the medium. We changed the rate. So again,
wow, gravity.
You haven't changed it.
So we're in control again of the independent variable. We're in control of the science. And we're in control of the conclusion here, you see?
Yeah, but Kimo, you're not understanding it. It's simply that. You're not controlling that rate. Because the rate would be how you nullify a scale or even the pulling force of a helium balloon. Mm-hmm. And that is nullified at 9.8 meters per second, no matter the damn medium.
Yeah, if you change the medium, the rate changes.
No, if you change the medium, nothing happens.
Does that happen?
No.
Does that rate?
Let's take an elevator full of water and drop it at 9.8 meters per second squared.
What,
the balloon stops falling and the weight stops falling in it. It doesn't matter what's in it.
Underwater?
If it's full of water, same thing happens.
No, underwater, does it fall at that rate?
Yeah. At 9.8 meters per second squared, those two things will become weightless and stop sorting by density.
Do things fall underwater at that rate?
No, they're broken by the resistance of the water, but if I move them at that rate...
The medium, you mean?
If I make them accelerate at that rate, they become weightless.
I know, yeah, but objects underwater, do they fall at 9.8 meters per second?
Not naturally so, no. But if you accelerate them at that rate, they do become weightless.
No, I know if I accelerate, I get that. But I'm just saying, in general, in nature, just generally.
No, Kimo. If you get that, if you accelerate them at that rate in a box, and you then nullify gravity, the cause of things falling and having weight, if that is nullified by that effect, then that is the measured result. 9.8 meters per second squared. You have done nothing to nullify the observation.
I'm not arguing with the rate, what you've measured, but I'm asking, does that rate happen everywhere?
Yes, that rate nullifies gravity everywhere.
But underwater, things fall at that rate.
No, but if you move them at that rate, if you accelerate them at that rate downwards, you nullify their weight.
Kimo, can I ask a quick question?
You sure can.
If you have a chamber inside of a very dense object that falls in the water, and that even though the rate that object falls in the water is very slow relative to in air, if you have a chamber of 1 atmosphere, why would the stuff in that chamber fall at the rate of 9.8 meters, per second squared, when it's inside of an object that you agree has a different amount of density?
Drop it from a mile high.
From a mile high, you're inside. You're still going to fall inside at 9.8 meters per second.
You've created its own atmosphere in there.
Yes. So why would that matter?
Because
why does that matter?
That medium is what gives you that rate. Remember, the medium, the density is the cause of these things.
But density, as you understand, is the amount of stuff in a volume. That's all density is.
That's right. Now you're measuring it, right? So that's the cause.
Listen. Hold on. If density is nothing more than the amount of stuff in a volume, and you have a volume within a larger volume, right? And the amount of stuff in that larger volume is of a average density of whatever, how can you have two different rates of falling inside the same volume?
Because then,
I mean, based upon how you're interpreting this, you have two different rates of stuff inside the same volume falling.
Yeah.
Very contradictory to me.
Yeah.
Yeah. So if we put water in that same container while it's falling and drop something in, it's going to drop slower through the water.
But if you don't, then it doesn't drop slower.
Anyway, so that experiment doesn't work for anything.
No, it doesn't drop slower. They both float. The medium does not matter.
It's just proving that the medium changes it, but the medium does not change the gravitational acceleration.
No, the medium controls the pressure. The medium controls the pressure applied to the object.
No, it doesn't.
It changes the terminal velocity, but that doesn't do anything to change the gravitational acceleration.
So when we increase the pressure, the object starts to move. You'll get direction due to density.
Are you saying the pressure on an object inside of it?
But again, as scientists, we're only looking for cause and effect. So if something's moving, we want to know the cause. What caused that to move? And the density caused it to move, caused pressure on the object and caused it to move. You see?
I told you, the cause of things having weight and falling is an acceleration, an observed acceleration of 9.8 meters per second squared. If you nullify that by moving things, having a thing move down at an acceleration of 9.8 meters per second squared, that weight goes away.
Oh, let's not get bogged down.
We're not asking why that acceleration is there. The acceleration is there, and if you nullify it, you get weightlessness. There's no argument here. You have nothing from that. If you can nullify it, then it is that.
Where does that happen in nature?
It doesn't have to happen in nature.
There you go.
So
the end.
If I can make it nullified,
welcome to Flat Earth.
Oh.
But I just want to say one thing before I hand it to Baked Beans. He's back now. He wants to tell you why he doubts the globe. But the idea is that you've got a container with pressure inside, and the air or the atmosphere or the gas, whatever you want to call it, outside of that container is constantly trying to equalize. So therefore, once it's equalized, you cannot weigh it if something's in equilibrium. There is a balance or if it's at rest, and that's the reason why you can't measure the atmosphere outside with a gauge, a pressure gauge, because obviously there's no pressure. Because once something's in equilibrium, like I say, there are no forces acting on it, and therefore it will apply no pressure when you try to make any measurements. So that just demonstrates that you have
inflation of nonsense right there. Well, you have nothing right there, Kimo. If I told you, no, if something accelerates down, you have a scale inside it with a weight on it, and it's accelerating down at 9.8 meters per second squared, then that scale will reach 0. There's nothing to do with the pressure of it, if there's water in it, or if it's made of bananas or anything.
If you put helium in a balloon and let it go, it'll go up. So what's your story?
And if you have that helium balloon on a pulling scale inside that same chamber, and you make it accelerate down at 9.8 meters per second squared, that pulling scale is going to go to 0.
Okay, so look,
with helium, what you're saying, flat Earth, it will not occur.
So look, if you've got helium in a balloon, you pop the balloon, the helium now will do what? What will happen
inside that chamber? Is just going to flow around.
The helium. What will happen to the helium once you burst the balloon?
It's going to disperse. So what?
Disperse where? Will it go to the ground, or will it stay where it is?
In the falling chamber or in the outside?
Just outside. You've got a balloon, you burst it.
Outside is likely to go up. Yeah, so what?
Alright, so let's go through it. It'll go up and go where? What will happen to the helium?
Oh, eventually it will cool and some of it comes down and some of it goes out. So what?
Some of it will cool, will go down because it becomes more dense. Yeah, it will contract. So the ones that are going up...
More dense? No, wait, what do you mean becomes more dense? How does an atom or a molecule become more dense?
Because it starts to collect with other molecules, like rain, like snow.
Slow. Let's put that.
Invoking the imaginary atom.
Yeah, that's if you believe in that. But what I'm trying to get from Sort, so you've got the helium now in the atmosphere. You say it's going up, right? Where will it go? What will happen to the helium?
Some of it will escape, and some of it will cool and stay in the atmosphere.
What, just flow around the air, you think?
Yeah, no, I know, because helium is made.
You don't know. You don't know. You think you know.
You know.
You don't know. You know. You think you know.
What is knowledge?
I know how you make helium for welding.
What does it mean to know something?
But what I would propose, Sort, is that the helium would go up, find its layer, its resting place, and then it wouldn't go up or down. It would just stay in its relative density field layer.
Think when I buy helium, Kimo, you think when I buy helium?
I know I've got a big dick, yeah, but I don't know that everything I've been taught about gas molecules all bounce off each other and getting kinetic energy, and some of them escaping the atmosphere and some of them not coming back down due to fucking the force of gravity isn't something that you can actually know. That's something that you can hold to be believed to be true from what you've studied and what knowledge you've acquired. But if you've not studied the other alternatives or tried to understand them with a free mind, then you can never truly know what's what. Thank you.
Oh, the thing is that I know how you make helium because it's filtered out of the atmosphere. And
I just wanted to know where you thought it goes.
Filtered out
but
of the
can we
atmosphere.
Let's
comes out of the shut up. If it comes out of the atmosphere, it has to be in there mixed somehow. If it is in there mixed somehow, it must be in every level, unless you're claiming that some magical airplane goes up high where helium is equilibrialized and takes it down here.
No, I just wanted your thoughts on it. I mean, obviously we understand. Obviously we know the answer, obviously, because we understand density. I just wanted your opinion on what you thought happened to the helium once the balloon has burst. That was it.
Some of it goes up, but it disperses into the atmosphere. Same as
in all directions.
In all directions, yes. And it mixes a little. Same as a little bit of oil mixes in water. Not a lot, but
it doesn't want to be next to helium. It just wants to go away. Just go. All gases just want to go in all directions. None of them want to form a skin.
Since I have serviced a plant that makes helium from the atmosphere, I would like to claim that I know how it gets from the atmosphere and into a canister.
But I wasn't finished, I wasn't finished with this question. I wasn't finished with line of questions. So let's say we've got the balloon now of air underwater. So we take it to the bottom of the ocean. We burst the balloon. What will happen to the gas inside the balloon?
It's going to go up. Yeah, show what?
It will go up and go where?
I don't know. Up, disperse into the atmosphere,
and then go where?
And then disperse into the atmosphere.
So will it keep going up?
Some of it. This is lighter, some of it will float. It's the same as I don't know. If you have
all right, let's wrap it up.
It's gonna float high, right?
Let's not press you too much. Look, let's bring in a baked bean. Baked beans is your mic working? Your connection is all good?
Yeah.
Okay, so we're gonna kick you off with why are you skeptical about the globe? What's the problem?
Well, really it all comes down to whether we can be sure about the heliocentric globe model, and I would contend that, to be honest, we cannot be sure of it, and I have a few debunks ready to go for anybody that challenges that. And I can give a couple of them here.
Yeah, well, first of all, just give us one issue. Give the Globers the first issue.
The main issue is the mathematical models that it's all built upon. It really becomes a problem of whether or not you accept the abstract mathematical models that they are built upon, and I, for one, am not so sure.
Hang on.
Let him finish, please. Let him finish. Come on. Who's that? Let him finish a little minute. Go on.
Me, Kimo. Shut up.
Come on, Rocket Size. Give him a chance. The story time.
And so, really, if we want to go into the Big Bang, heliocentric globe theory bullshit, we can. And I have a simple debunk that is only about 3 sentences long that completely and utterly debunks it. Okay. If we want to go into the mathematical abstract models that it is built upon, we can do that too.
Mm-hmm.
But at the end of the day, it seems like it seems like it is very, hold on, just give me 10 seconds.
Give him a chance, guys.
It's extremely easy to cast doubt on it, and I think that we have done that because we're skeptical of it, and they haven't even thought of the simple and obvious things that become issues if you actually look into it. So
sounds good to me. Mate Bean, sounds wonderful. Give us the first problem so the guys can get their teeth into it.
Yeah, so we give the 3 sentences.
Yeah, we give the 3 sentences.
Three sentences.
The 3 sentences. And he was in the YouTube chat when he said it.
Satellite, stop, please. And first it will be curved, rocket, and then satellite to answer. Let's get 3 sentences.
Okay, well, if you want, for the something comes from nothing type people, the argument is only about 3 sentences long, and it utterly destroys it.
Let's hear it.
Destroys it.
You're the bunk, dude.
Okay.
You're the bunk.
So the first premise is that something cannot come from nothing.
That's nice.
The second premise is that the heliocentric globe model posits that something does come from nothing. And the conclusion is that, therefore, the heliocentric globe model is an impossibility.
It's the same as fucking bullshit. I will laugh at that.
Come on, how are we going to have a conversation with this cackling?
No, he has no clue what the theory says.
You get 45 seconds, Termin, to say it. Can he say his bit?
First, shut up.
Right, just ruin the conversation.
That was the entire...
Right, now show me where in that theory it says something came from nothing. Rhetorical, you don't know that. You twat.
Great conversation. Great discussion.
Spurs, shut up.
Great response.
I didn't give you permission. Shut up, Spurs. I didn't give you permission to speak, bitch.
Nothing. Bang. Giant fireballs. Monkey men. Any questions?
So, I mean, I guess they've all heard the argument before. That's fine if you don't want to.
It's not an argument. It's a lie.
You know,
no, it's not true.
They all say, "Oh, well,
there's never been any such thing as a nothing. I've never seen nothing demonstrated to exist."
Baked beans. You sound like Nathan Thompson.
And also, Beans, I heard you the first time. Not heard you, but I read you.
Who are you calling,
David?
Monkey Man? Who are you calling, Monkey Man? That's racist.
Baked beans. Are you Nathan Thompson?
Alright, so I'm going to have to bring order in here somehow, some way. So, does anybody want to respond to Baked Beans' premise that something...
Yes.
Okay, Rocket, give me 45 seconds. Let's go.
Baked Beans, what you said, it was absolutely ridiculous. You conspiracy theory do this all the time. You conflate the Big Bang Theory and then you connect it with everything else. You try to connect what your disingenuous belief of the Big Bang Theory is into something else. The Big Bang Theory, whatever how else it caused it, is actually decoupled from the heliocentric model. I don't know where you think you can take a connection from there and link it over to there. You made an absolutely ridiculous claim, absolutely ridiculous assertion that has no connection. It's not even worth debunking because it is that ridiculous.
Okay, well, that's fine. For you people that support your version of the heliocentric globe model, we can still debunk you. That's fine.
No, Big Bang is not a prerequisite for neither heliocentrism nor evolution. You're simply just conflating things. It is a theory that incidentally explains things, but it is not a prerequisite for anything.
I don't think we ever...
It has to have... Well, anyway, sorry, I didn't mean to interrupt.
No, go on. I was thinking, do you understand the question or the rebuttal from Rocket?
Yeah, I understand what he's saying. Fine, okay, fine. His model does not have to have that as a prerequisite. Fine. We can still debunk it, and that's fine. If he is not supporting that particular version of the heliocentric globe model, that's fine. We can still debunk it, and we'll get into it.
One second. No one supports your version of the heliocentric globe model the way you presented it.
Well, I would beg to differ, but
ask anybody in this room. Ask anybody here if they support it.
Buddy.
Take a poll of the Globers in this room. See if they support it.
well, I'll just tell you that apparently that some of the top physicists do support this model. No.
I read who the top physicists are. None of them do. You're full of shit. Give me a reference if you're actually claiming that.
What's he calling this model?
Everything, I guess. He's just saying that
damn it,
came from nothing.
Look, you lot, stop being dishonest and give us your version of then, rather than sitting there saying, all right, no one said anything come from nothing. You say it's an unknown, yeah? That everything came from an unknown before the Big Bang, and then it came into everything. But you said it's a singularity, so everything that you do know came from a single point, like on the top of a pinhead.
Speaking, said something.
Yeah, he was, and I'm just going to reiterate his argument because everyone's just trying to strawman him and not answer the questions. If you guys know what the Big Bang is better, then you explain it yourself.
All right, so look, Brummy, you got hold on, Curb, because it's getting out of order now. So, Brummy, do you want 45 seconds?
Yes, please. I just want. People attacking Beans now.
Come on, Curb.
All the people that are attacking.
Trying to direct traffic here, Chemo. You don't know what the.
All the people that. Everybody's attacking him, right? Now I'm sticking up for him. Everybody's jumped on him. Everybody has. So now it's your turn to listen to an attack back.
I asked him a fucking question of what he's referring.
Everybody asked him a question, Curve. Everybody did. 4 people asked him a question. So rather than sitting there asking questions, why don't you all give your version of what the Big Bang actually says then, rather than just saying we never came from nothing. All right then, it was an unknown. We all came from an unknown. It's another way of saying a nothing because you don't know what the fuck it came from. It always a singularity and exploded into something. Then fucking spaceball monkeys came out of nowhere.
10 seconds.
See what you've done, Chemo?
Well, Curve, you get your 45 seconds if that's what you need.
Dude, all I wanted was just for right now, what is he talking about when he says this model? He's referred to several different things, and I want to know what he means. Can he, and he alone, answer the question that's asked of baked beans?
Absolutely.
Yeah, so that's fine. If your model does not posit that there was a Big Bang, then that's fine. Like I said, we can still debunk that, but if your particular model does not, then that's fine. But I do want to say that there are top physicists who do claim that it does all come from nothing. So
sure, okay. Well,
I mean, I don't know what your issue is with it.
Beans, the argument
later, you can be in for a chance.
Beans, the argument isn't whether or not the Big Bang is valid. The argument is that it's irrelevant to the heliocentric model. You can have a heliocentric model with or without the Big Bang.
And I disagree, Truman. It's not that he doesn't listen. I think he listens. He knew what the question was, and that's how he knew exactly what to avoid. That's just my 2 cents.
Baked beans. They said that you can have
the same result.
Baked beans are saying the Big Bang is not necessary. This nothing is not necessary. How do you respond?
Well, he confused the two.
Well, their entire physical model that's what they claim it comes from. So I'm not understanding how it's not necessary, but that's fine.
Oh, I'll tell you what you can do then. Okay, no. Okay, let's say, Baked bean. Let's say they did say this. What was a rebuttal to it anyway?
Well, what do you mean? My rebuttal was simple. It's just that something can't come from nothing. The heliocentric globe model posits that something does come from nothing, and therefore the heliocentric globe model is
the heliocentric globe model doesn't require the Big Bang. We could have literally just came out of some unicorn fart for all we know, but the Big Bang makes more sense than a unicorn fart.
Why?
Well, because we don't know that, because unicorn farts, we've never seen a unicorn the size of like a solar system.
You've never seen anything else.
Well, the expansion can be projected back to such a degree that it would not for unicorn farts to be a reasonable assertion. So you have to at least neutralize.
So anyone going to tell us the Big Bang story, or what? Are you going to sit there just being idiots? Tell us the Big Bang story. Give us the fucking the real fucking Iron Man version of this Big Bang story. Come on, just tell us the story.
Big Bang doesn't matter about the shape of the planet, Brummy.
Billions and billions of years ago, what happened? What happened billions and billions of years ago? Please,
I think actually it's a singularity, right? So you had a single point, and then everything came.
Infinite mass, which is a lot different than nothing.
So baked beans.
Infinite mass.
Baked beans. Do you ever think about singularity and the idea that everything came from a single point?
Yeah, I see kind of what they're saying, but where did this singular point come from? I mean, it just raises more questions, and
but we don't know. Not even a proper question.
Doesn't change anything.
So
Nate, it doesn't matter. I'm sorry. Whatever your name is, I'll just call you Nate for short. It doesn't really matter.
Baked beans. How do you account for people who don't believe in the Big Bang Theory? They believe that God created the universe not by the Big Bang method, but still accept the heliocentric model.
Well, they're not actually. I mean, most people do not question the world that they live in, and they don't really care how it came about or any of this kind of thing. So, an appeal to what the majority think is not, in my opinion, going to work here.
Plus, it goes to the heart of the thing is, if you're willing to believe that you came from a singularity, you're willing to believe anything, whether you're on a ball, whether you're a spaceball monkeys, it all starts from that. You have to really consider everything you've been told to digest. This evolutionary bollocks.
Third time,
the Big Bang
we
bollocks.
don't need
the shape
the Big
of the Earth
Bang.
bollocks. I don't care. It's part of the whole puzzle. It's part of the whole thing. It is related. You need to get it in your head.
Check back later and see if a serious conversation is being had. Good luck, y'all.
Okay.
Rami, you're descended from apes. All
right, let's move forward a little bit more. Baked beans. I'm sure that wasn't the only thing you had in mind, right?
It was.
No, it wasn't.
Hey, guys, we have to do better than this, guys. Let Baked Beans speak a little bit. What else did you have in mind, Baked Beans?
I know there are many, people who say that, we don't need the Big Bang to explain everything and blah, blah, blah. So, that's fine. But what we do have is we have Gödel's incompleteness theorem, which tells us that math cannot be proven to be consistent. And so we have a little bit of a problem here when we have the heliocentric globe model built on an entire mathematical edifice that all of a sudden it's on a shaky foundation.
Wait, what was the name of the
The problem is now the entire thing is on a shaky foundation because physicists use the same math.
What was the name of what was the name of this maths you said? You said a particular name.
I posted the link.
What is the name of the what? Sorry, Chemo, I didn't hear you.
Gödel's. It's not Gödel's the way you pronounce it.
Gödel's.
Yes.
Okay. Rocket, this is for you. Explain why Baked Beans is incorrect.
Honestly, to be very honest, the ridiculousness of his assertion it's self-evident that it's wrong. I don't understand why anybody's even giving this guy any credence about what he's saying. It really is that ridiculous. First, let me finish that thought. I do orbital mechanics on a daily basis. I don't fucking care whether there's a Big Bang or whatever the hell caused it. I don't use those in the equations that I use on a daily basis. So how can you conflate the fact that the heliocentric model is connected with the Big Bang theory?
Because it's all based on the same theories that brought it about, and if you...
No, it's not. It's absolutely not.
The earliest sort of...
I already said to you why. No, but I've already told you why it's related, because if you're willing to believe you came from a fucking singularity, you're willing to believe anything. No, you're willing to believe anything. That's what it's to do with it. It's to do with what you're willing to believe. You're willing to believe billions and billions of years ago there was dinosaurs, there was Neanderthals, there was this, there was that.
Broomy, it's why you're willing to believe it, and that's the part that you don't distinguish well.
I distinguish it very well. It's very related.
Then why
you don't get why it's related.
Believe that
you don't get why it's related.
random...
You don't get why it's related. That's why I'm explaining it, because I already told you once it's related. You don't see why it's related. It is. You think it's not.
It is irrelevant.
No, it's
in the context of the heliocentric model.
No, it's not. It's about what you're willing to believe.
Rami, I have a container of gum on my desk right now. It has like 5 pieces in it. Do I need to go back to know that like it came from a factory and every single ingredient to know that there's 5 pieces of gum in here?
No, but you do need to know what I'm willing to believe, and what you're willing to believe is part of this whole fucking reason that everyone's been lied to about the shape of the Earth.
Why we're willing to believe is also important. You're going to go there, Broomy.
For the globe.
Are you trying to understand what I'm saying, or are you just trying to misunderstand it intentionally?
You're omitting something.
What you're not understanding here is...
Oh, yeah, you're just trying to misunderstand. All right, no worries. No further questions.
No, bro. Let me explain it once.
You're roboting.
Now, the theory of the Big Bang is just a theory. It has sense that it could be that. But, it just because it makes sense and it explains things that it could be that, it does not implicitly mean that happened. It just means that maybe that happened.
Really? Really?
Yes.
Oh my God, you're so intelligent. Do you understand what I was trying to say? Do you even know what I was trying to say? Do you even understand what I'm trying to say?
All right, this is interesting. Let's.
You see, the thing is, the real point of this is that if you have a theory, some knowledge that it happened in one way, you're just saying, well, maybe it's that, and not bothering with it to go on with the other stuff. It is not. If it's somehow proven that.
Oh my God! You don't get my point. You're just talking words. You're not responding to what I said to you earlier. I told you, if you're willing to believe, it's like if you're willing to believe billions and billions of years ago that dinosaurs were created, then you're probably willing to believe the shape of the Earth is fucking round. Do you understand? No, fucking answer what I've just said. Don't tell me a story about fucking what is and what ain't. Just respond to what I said.
See, the dinosaurs are not theory, nor is the shape of the Earth. They're facts. They're known facts.
So you're willing to believe the bullshit? That's the point. You think the Earth's fact? You think the fucking you think dinosaurs are a fact? You're a spastic.
Dinosaurs.
You can see evidence of.
I dig in my backyard. I've never found a dinosaur.
Evidence.
Oh my God.
Yes. What's it to do with the shape of the Earth?
So if you can't see it with your eyes, it doesn't exist. That's the flat Earth philosophy.
Dinosaurs are real, so the Earth is round. They're facts. Yeah. What has it got to do with the Big Bang? Oh my God! You got dumb.
If you can't see it, it doesn't exist. Right? Is that what you asked?
Yep. The flat Earth philosophy.
Can we get back
That's
to
a pretty good philosophy.
The main point here,
because unicorns don't exist, but if you believe in them like you do, I don't buy it. You have to show me the unicorn.
Air? Can you see air?
Well, can we see your dome? So it doesn't exist. Done.
We can see the dome.
No. Can you see air?
Depends. Normally, no.
You see how you're avoiding a basic question. You guys try to be so direct, and you get it right back.
Humidity.
Can you see the air? Yes or no? Flat Earth.
No. Can you?
So are you going to say that the air does not exist?
I can manipulate the air, though.
Can you manipulate the dome?
No.
If I could go that high, I probably could do something to it, but we're not allowed to go there.
No. Oh, we're not allowed. Oh, there's the appeal to authority.
No, that's the fact.
No, it's not a fact. It's you making up a story that's false. Just like your nonsense about you can't go to Antarctica. I'd love
you can't go there. Let me see you go there.
I'd love to see if one of you guys try and be turned away.
Why? Why do we want to be turned away?
Because you need to prove your point. You made up a lie, and you expect us to accept it as valid because you're so conspiratorial about it. Like, oh, this terrible thing you can't do, this amazing thing you can't do. They are preventing you from doing it, so that makes it more valid. All you got to do is put the word they and allow in a sentence, and then the flat earther seems to have a valid argument.
I 3D printed a dinosaur. Does that make it real?
Did you analyze the 3D printing to understand the dating of it, where you found it? Does it
created
match the
it.
area that you create? No, hold on. But when people find these dinosaur fossils, they're not finding them at the bottom of a printer. They're finding them digging it under 20 or 30 feet of ground that hasn't been touched in all of known history.
I have one question for him.
T-Rex was designed from what, a tooth?
Apparently, according to you, they're all designed from a printer.
Hold on, I got a quick question for him.
Sorry, guys.
That dinosaur that you would supposedly make from your 3D printer, does it have fossilized bone cells in it that you can see through a microscope?
I haven't tried yet. I'll look.
Yeah. So your point is retarded.
I haven't tried yet. How can my point be retarded if I haven't tried looking with the microscope yet?
Oh yeah, what's this dinosaur made of?
Oh yeah, there's diamonds that you can actually forge diamonds, and they're supposed to take years and years of carbon underneath the earth, and they could be counted.
That doesn't count. That you can manipulate matter like that.
So what you're saying is you can manipulate matter. Okay, cool.
You can distinguish normal diamonds.
Yeah, you can. Yes, you can. Yeah, I know you can because there certain ones have certain patterns in them. But at the same time, what if they could? But let's think about it. Hold on. Let's think about it. If there was a way to do it where they could fake it, you wouldn't know about it.
No, we can distinguish them.
You wouldn't know about it.
We can distinguish them.
You wouldn't know about it.
Yes, you wouldn't know, but I would.
What is the point?
You wouldn't know.
That's the difference.
You can tell the difference between it, and and these things were discovered long before anybody could have faked any kind of a cell or anything like that. So I'm at a loss as to how you guys think that this is a win for you.
Well, before they went to the moon in a flying tin.
Yeah.
Yeah, around 1850 or something, right? That's when they discovered dinosaurs.
So
right around the time when they decided that they needed to fly in space.
They started finding dinosaurs.
From me, that was not pure incredulity.
That is useless. They started finding them.
So Nate Thompson, do you have any other arguments with your presence here now?
I don't think it's Nate.
Yeah, it's Nate.
It's baked. I mean, it sounds like him, but he's not. He's way too kind to be Nate.
I think that's Thompson trying. He's like, okay, let me try a different tactic here, but whatever.
But before we move on, I just have one more comment about the Big Bang thing. That even if we allow, even if we allow that it's necessary for the heliocentric model to work, which it's not, but even if we allow that for a moment, there's a misunderstanding about what the Big Bang states. It doesn't state anything about what happened before the Big Bang or where that matter came from. In fact, there's many different options for what it could be. Like, for the longest time, we thought it was a cyclical Big Bang universe where gravity would slowly pull it all back together to one infinitely dense point, and then it would explode again, like cyclically. And then there's another version where it's cascading, where there's essentially, mathematically anyway, there's no difference between a universe that has reached maximum entropy and an infinitely dense point. So it could cascade in a way by ever expanding. There's lots of different options. In the two that I just listed don't require that matter has to come from nothing, right? So even the premise is wrong.
I've got another one as well, though. Do you know what my favourite one is? They're all a load of bollocks, and obviously it was created. Do you like that one? That's one of my theories.
But your alternative is that some being that you can't explain where that being came from created it from nothing, and that sounds. You don't need to explain where the creator come from. That's just another way of you trying to. Why would you need to explain where this came from?
Because that's its creation. We are its creation.
But Brummy, why is it you tell us that we need to explain the whole Big Bang and all this stuff, but you can't, but you don't need to explain your creator?
But
God
so
don't require explanation.
Is the universe eternal? Is that so that's what we're going with?
Well, some theories yes, some theories no.
So baked beans, when you see, like, as you are going after the heliocentric model, when you see the sun disk in the sky and it's moving through the sky and it's the same exact size in the sky for you, for me, for anyone at any point in time, how do you rationalize that by saying that the sun is close and more local when the distance changes and you have to understand that when something is further away, it looks smaller in the sky?
Yeah, I understand the laws of perspective and all that. I simply say that we don't know what it is, and it's up in the sky, so we can't really get a 3D kind of view of it. We can't observe and test it here on the Earth. So my view is we don't actually know what it is.
Why do we need it to be on Earth for you to test?
Is it a reasonable position to sit there and say, let's throw out all knowledge and then just revel in ignorance? Is that really a reasonable position?
Nate, I busted you open, bro. You've been exposed. Thank you.
Do we need to know what it is to tell where it is?
Like, do I need to know that you're Nate to know that your arguments are bullshit? No.
Well, we know that it's a light coming from up there, but I mean, we cannot. We can't get to it and kind of look.
You don't need to get to it, though. You listen. The way that you interpret what you see is not even consistent to what you see. You see a disc. The disc has an illuminated intensity. That illumination changes over time. You say that the illumination would actually change over distance. You're postulating that it's closer, that it's therefore,
I never straw man. I never said that it was closer necessarily.
Oh, okay, great. So you haven't determined anything about it, but you take what we have learned about it and dismiss that knowledge as not knowledge because we haven't physically touched it.
What have you learned about it? It's a light, we know that, and it has heat. Okay, we know that.
It's made of primarily helium and hydrogen.
Nope.
We know that.
Nope.
Yes.
Nope.
What do you mean? No. Why are you saying no?
We have bounced radio waves off of it. We've been to it within 3 million miles.
Yeah, right. Because you can't have gas pressure without a container.
Why not?
Well, that's what you say.
Why not?
I can prove that wrong.
Have gas pressure without a container? I'm sorry to interrupt. Go ahead.
I mean, I can prove that wrong, essentially. That
you tell me why you can.
I can have an open container with gas pressure in it.
Hey, don't forget the communist Chinese are on the dark side of the moon over there too. You always got to mention your communist.
I can have an open gas pressure in a container next to a vacuum. I can have that.
Yeah, but can you have a gas pressure inside a get your bucket, put some gas in it, swing it round inside of a vacuum and see if the gas stays inside.
It will.
And that's a container, by the way. But that's still a container. You do realise you're using a container
to vacuum
gas pressure without a container
next to a gas pressure. So I mean, I could have 100 PSI next to a vacuum inside of this container.
The one container inside of another container.
Yes.
Yeah. So you need a container for the vacuum. Hold on.
Next to
let me get this straight. You've got a container, right? And it's a vacuum. You suck all the air out of it. Then you go inside this container with a bucket. You put some fucking water or some gas in the bottom of it. Let's say you put some gas, yeah? You swing this bucket around, even though it's a container anyway, and it's got walls on it. It might be an open container, but you swing it around. You're saying the gas is going to hold in the bottom of that. It's not going to suck out into the vacuum.
Absolutely.
I need to see that then.
That's another imagination experiment.
I'd love to see that. Get you know when you do the volleyball, you drop it down. When you do it in that vacuum, get BBC to fucking swing the bucket around, put some gas in it, and fucking detect it not escaping out. And that's in a container. So you're not even using an open. You're using an open container, but you're not actually using it. You still can't have a container.
Containers are irrelevant.
Gas pressure without a container.
When you're looking at the basic physics of what you're saying is the problem. You're saying that gas pressure will try and equalize with a vacuum.
Yeah.
So it doesn't matter that the container is there as long as it's open. So I can have next to a vacuum a pressure. So it doesn't matter whether it's in any way, shape, or form that there's a bucket there. It's the fact that I can get something to stick to the bottom of the pipe.
No. It does matter because it's like using a plate. Yeah, if I had a plate inside of a vacuum and I put centrifugal force on a plate, when it's just it's a surface, but it's an open surface, like the Earth is an open surface. It's not an open container. It's an open surface.
Oh, I got
an open surface. We're an open surface, not an open container.
You do realize, from when you used to be a ball earther, that there's a force called gravity.
Yeah,
and that the air pressure. If you took a bucket of air and poured it on the surface of Earth, and it would go all around. It would spread out in all directions, but it would tend towards the ground. So it would go around, and then you keep on adding air to it. It would keep on building up and building up. And pressure would build up on the ground. You realize that because it's an equal force pulling in all directions.
Right. What I realize is an open surface. Yeah, you've got an open surface. Then you add some centrifugal force to that open surface, which will recreate the gravity, which is what you're trying to use in your analogy.
Yes.
Yeah. So let's get a plate inside of a vacuum.
Yeah, why do you want to use that plate around? It's going to fall off.
Because a plate is a surface. It's an open surface, not a container. A bucket. Oh no! Shut up! A bucket is a container. A bucket is a container. The Earth is an open surface. So a bucket is a container. You can't use a bucket. You can't use a bucket. You have to use an open surface. Add centrifugal force because the Earth is apparently an open surface.
I mean, it really is.
Make it easier for them and just put a globe in the vacuum and then do it that way instead of a plate. We'll give you the round globe. We'll make it for you.
You can get the force that I can use to pull in on the oxygen.
An open surface with centrifugal force on there and a bit of gas and it sticks inside of the vacuum. You're stupid. You're the one who believes this nonsense.
Is a moronic.
You're the one who believes that this. You're the one who believes this is possible.
You are a classical moron.
I'm trying to. I'm showing you your argument. An open surface with a bit of centrifugal force on it will keep the gas on it. According to your logic, that's your argument.
No, that's not my logic at all.
You want to use a contained bucket with you want to use a contained bucket with sides and
why doesn't it equalize?
The gas?
Why doesn't it equalize in a bucket?
You're saying the centrifugal force is causing it to stick to the container with the surface, so you don't need
the pressure would go up. The pressure would go up on the plate, though. If you're spinning a plate around, you would have a localized increase in the air pressure on the surface of the plate.
Yeah,
absolutely true.
Yeah.
So you'd have your force, because you're saying it's only the force that's holding it together, not the container. So you can't have a container because you've got an open surface. So get your argument correct. Get your argument straight.
My argument is straight.
No, it's not, because you're talking about a bucket.
Why doesn't it equalize? I've got
because you're saying gravity. You're saying gravity is causing the gradient on it. All right, I'm done.
What is the flat Earth reason for why it does not equalize?
Why does he's trying to say gravity? So I'm trying to use the force just the force alone to be the responsibility of keeping the gas to the surface. It's an open surface, not an open container. What?
So my question.
Actually, that's going to flat remind me. Like, you have a dome.
Yeah.
You have the atmosphere. Why is there a pressure gradient with increasing altitude?
The biogeochemical cycle.
Oh my
causes
God!
A gradient inside of the container.
Mute him.
Heat, convection, all that takes play. Humidity, everything. It all swirls around.
Hold on.
Swirly.
In a dome, the heat from the sun making that hot air rise.
Reversal of burden of proof. Reversal of burden of proof.
Let me finish my point.
No one talks to you.
The hot air rising. It should be warmer as you go up.
Yeah, let's talk about the dome. Let's talk about the dome, ladies and gentlemen.
Yeah, the dome. The dome that makes things colder as you get closer to the sun.
With your fucking surface, open surface container fucking bullshit.
Yes, open surface. What's your problem? How do things get colder as you go closer to the sun?
Why are you changing the subject? Listen, you've got an open surface with a bit of gas on it. Swing it around with your centrifugal force and see if your gas can stick to it inside of a vacuum.
The centrifugal force is offset by the gravitational force that you refuse to acknowledge. You refusing to acknowledge something is not our problem. You can randomly not acknowledge whatever you want and then say, well, this whole argument of yours globe earthers, it doesn't work because I don't believe that this part of your understanding is valid. It's like, why don't you think it's valid? Because I'm not liking it. It's like you have no reason to discount gravity. You keep trying to re-explain why things go down, but you can't explain it consistently.
We have called into question the entire mathematical edifice created by the heliocentric model.
Nate, I knew it was you as soon as you opened your mouth, and you know how I know it's you? Here's the proof. You, what's your name? What's your fake name? Baked Beans. I will never see you and at Nathan Thompson in the same room at the same time.
Done. All right, well, if you think that, all right, I gotta go for a second, but I'm gonna be right back, and I'm gonna completely debunk your entire.
That's 100% Witsit. Right. Thanks, Austin.
Yeah, Witsit, Nate Thompson, whatever. Freaking trying to be Spider-Man and shit.
Wits Thompson.
Dimwit.
It doesn't sound like Witsit at all.
It sounds like Nate Thompson 100%.
Yeah, it does sound like Nate. It doesn't sound like Witsit.
But the thing,
elements of both. I can see why people would say one or the other. FYI.
Yeah. But the thing is like this dome and how the fundamentals of this is that the dome is invisible. You can't measure it. You can't seem to interact with it. But you are interacting with it when it keeps gas from escaping. So if it's able to keep gas from escaping, it should be able to affect how gas behaves near the surface of it. You can have pressure waves near it. You can have high and low pressure systems, right? You have all these ways that gas works when it's near a surface, and it's not working near that surface. But it works near that surface because it prevents the gas molecules from escaping through the surface. Contradiction.
And how would such a structure even exist as a free-spanning one, right? This would like collapse under its own weight.
There's no such thing as gravity.
Whatever is making the other things fall down should be making the dome fall down with it.
The helium up there helps lift it.
The helium up there.
We call it fallity, not gravity, and then it's okay. Fallitude? Falliness. It's falliness.
You know what sucks about your dome? The dome is a dome, right? So there's areas of the dome that they're at low altitudes near the perimeter. The helium doesn't flow in a dome-shaped way to even make that stupid argument work. So you got the pressure, you got the size of that dome near the surface of the Earth, which should also create pressure differentials, shock waves of various speeds. The sun's heat should create convection layers somewhere along that perimeter. There's no convection layers that are consistent with the shape of a dome.
You don't know that.
Dude, are you serious? There's no convection layers that are consistent with a dome. Nothing. You don't see convection layers near the edge of Antarctica. Oh, look, there's
you see it down the equator. If you look at a flat Earth weather map, that's where you see convection.
Which is supposed to be the
so what? It's still moving all around.
No. Listen to what you're saying. You're saying the equator, which is for you what, a third of the way or half of the way between the middle of the dome, but it's in every direction. That doesn't work because you have greater. Well, you're saying the Earth doesn't turn. The dome apparently doesn't turn. So what convection layers are you referring to that are only
Who
halfway
said the dome doesn't turn or does turn?
Hey, if it doesn't turn, then there should be no explanation. There should be no reason that dome causes convection layers at the equator. That doesn't make any sense. And if it does turn, then there should be convection layers all over the place.
Well, it obviously turns because the stars are moving.
Now I got you.
I thought that was projection.
I got you. That's what I was hoping you.
Yeah, they circle Polaris.
So if the dome is turning, this is what
since the beginning of time.
You should be seeing high and low pressure systems that are consistent with the dome turning. Okay, that means that as you're closer to Antarctica,
you have other objects in there turning and doing other things.
But the only thing
you don't. You don't have other things doing stuff inside the dome?
Listen, this is easy. The only thing that interacts with the gas molecules is the dome, not the other things beyond the dome. Unless you want to count the sun, and then you got the sun heating up that air. I'm not seeing any dew.
Doesn't the sun heat up the air?
It sure does, and doesn't hot air
goes all over the place. Convection.
But you're not getting convections that are consistent with the dome. You just contradicted yourself. You messed up.
Do you have any proof of that?
Yeah, we looked.
Okay, let's see them.
Patterns. We looked at the weather patterns
on a flat map. Match exactly what they're supposed to do.
No, you just said match what they're supposed to do just to say it. You have to look at how you.
No, I've looked at the weather patterns working on the map, and they work.
No, they work, but they don't work.
Up and down roller coasters on a globe do not make a weather pattern.
I'm going to stop for the sake of the room, but I'm going to follow up if requested.
Flattened.
I'm sorry. I want to give the room time to speak. I've talked too much. I apologize.
Here's a thought. Does anybody know if the sun and the moon is inside the dome? I've never got an answer to that question.
They changed that. They used to say it was, and about a month and a half to 2 months ago, they said it's outside. There's a layer beyond the dome where the sun and the moon
There's
are no
7 layers, actually. The sun is on its own.
The sun jumps in and out occasionally, and so does the moon.
7 layers of the dome?
Absolutely. Look it up.
One for each of the planets.
Is that how that works?
What a coincidence.
What the fuck is that supposed to be? 7 layers of the dome.
Rocket, when the sun wants to jump into that thing, then it does, and then it jumps out and jumps outwards, right? And then it jumps back in. It slides through and it slides through the dome. When it feels like that.
Just imagine a very confused look on my face right now, because that's all I have. So. What amazes me is that as you talk about this dome, there's more and more complexity having to be added into this. When the heliocentric model and gravity is F equals M1 M2 G over R squared, that's basically all you need to model and explain most of the things that are happening.
What was that formula?
Are you kidding me? You don't know that one? You're arguing against.
I wasn't listening.
Position.
I heard you say something. Like, give me the formula you said.
I'm just going to tell you what it is. So you've got Newton's gravitational equation. Go look at it. Are you seriously telling me you're arguing against us? You don't know what that equation is?
I didn't hear the whole thing. I have my headphones on.
I shouldn't have to. Anybody in fucking high school has heard that.
Because you're going to prove every one of those items you're using, gravity and radius. You're going to prove it all.
Post it.
You have to prove it all. It's your burden of proof, not mine.
I'm the guy who can take you on in that equation.
You can't do anything.
With a high amount of confidence. Because unlike you who sweeps floors or sells hot dogs, what the fuck you do, I have a real job that works in the scientific and the technology field.
Hey, now stop that. He drives a high-low, okay?
Oh, yeah, okay, sure.
He drives a high-low at the plant.
Irritates me that you don't even know that equation. And I said it, and what is that equation?
Big man equation.
Are you fucking kidding me?
Big man equations. Well, your equations are good.
Next to somebody a hot dog, so I wasn't paying that much attention. You just piqued my interest with it. That's all. What do you want on that? Mustard?
No, relish.
I actually prefer relish with a little bit of mayo on top.
Chicago dog.
Could you do me a favor then? Equations. Could you write me an equation to give me gas pressure gradient on a plate spinning around with using centrifugal force as the fake gravity inside of a vacuum?
Or you could do that.
I mean, that's your homework.
Wait a minute.
I don't know what
my homework.
Your model.
Mr. Orbital Mechanics can't do that one.
Wait a minute.
Well, he's making up a nonsensical model, so why would I even attempt to try to model that?
That's the model we live in.
That's the model we live in.
Okay, which flat Earth?
Hang on.
The dome.
Here's why I'm not going to do it. You're claiming that it's a flat Earth model, and you're saying that it won't work on that. This is your burden of proof to make. You make the model, you show that it doesn't work.
No, we live on an open.
Why the fuck? No.
We live on an open surface, which is a ball. Yeah, an open surface, which is apparently a ball. Yeah, which is next to a vacuum. yeah, that has a pressure gradient that's caused by gravity, right? So we use a centrifugal force to replicate gravity. We'll put some gas on a little plate, and then we'll spin it round to reenact the gravity inside of a vacuum, and we'll see what happens to the gas.
Why do you say next to though?
Sounds
like
vacuum. You do realize when you spin the plate, the centrifugal force is actually radially out from the plate, not vertically from the plane.
We're going to have to figure a way to do that centrifugal force experiment that everyone keeps using.
Are you talking like an inner plate with a curved surface, or are you talking like a plate of steel?
The centrifugal force you need in that centrifuge will be massive because you don't have the distance of that atmosphere, right? You know, the atmosphere is well over 100 kilometers tall, and whatever
scale
you put in the plane.
Scale it down, man. I'm sure you got your maths to sort you out. Your maths will get there, won't it?
But
what you will get is you will need much higher rate of rotation, but of course you will have the pressure in there.
Just prove a gas pressure in a container.
Yeah, you have to be spinning more. You have to have more than 300 feet per second of centrifugal force. 300 meters per second at 70 degrees.
Gas pressure on a surface inside of a vacuum with a gradient. That's what we need.
I think the hardest thing would be measuring it, because the G-force in that thing would be a bitch on your gauges. Well, no, actually, if you just sample it off.
Theoretically, it'd be possible, wouldn't it?
Be a lower pressure in the center of the flat
Don't worry about the
than
flat
at the outer edges.
Don't worry about that. Let's worry about the globe. The globe has enough problems as it is. Let's talk about the globe problems.
Well, I asked you, do you believe that the dome is spinning or not?
Mate, Flatten, you're right. In Brummy's model, if you're sitting at the center point, you won't feel any gravity because there's no centrifugal force because your radial distance is 0.
And I'm wondering if
using my model,
would you be able to breathe in the center?
We don't live in a model. We live in reality, mate. We don't live in a fucking abstract version
And they
of the
still
world. We
don't
live in the real world.
get that, no matter how many times you tell them that.
a model.
Yeah, but the thing is, the word model is
models to describe what reality is, so that we can make predictions and have a better understanding of what they do.
Well, it isn't reality.
Brummy, I'm not saying. What did I say? I said we use models to understand reality. I didn't say that it is reality.
I know.
So don't put words in my mouth.
Yeah,
I know. I'm just reminding you that it's not reality.
So then, what do we use in place of a model to understand what we're seeing
and make predictions?
Thank you.
Test your model. Test your model by getting your centrifugal force.
Make some predictions, Brummy.
Put it inside a vacuum chamber. This was the prediction. So this is a globe prediction. Because if you swing a bucket above your head, it'll create. Well, keep talking over me. It's all right. Well.
Yeah,
predictions. If you want to disprove the globe model, the burden of proof is on you. The preponderance of evidence is on our side. So why the fuck am I going to do your homework for you?
If you want me to believe the globe model,
to be very honest,
out of a vacuum.
I have no desire to convince you. I don't give a flying fuck if you believe it or not. I just like laughing at you.
Broomy, just curious, why do you think that you can scale down the globe model, right, and then treat that scaled down version as being experimentally analogous?
Because you think that if you spin a bucket around your head,
under the entire gravitational
keep talking over me. Ask me a question and talk over me. That's how we go. Talk over me. Ask me a question.
Oh, I'm so sorry, Broomy. I'm so sorry.
Because you think it's okay to get a bucket, swing it around your head, and go, look, gravity. That's what you do.
No, that's not how this.
That's
works.
what you do. That's what you do.
We have.
That's what you do.
We have.
You're filling the swinging bucket with a gas in a vacuum, so when you open the gas, it's going to go everywhere. It ain't going in the bucket.
Fine, but that's because there's nothing.
But
the gas is going to move,
and
out of
it's
the
no longer a vacuum.
Rocket scientists, you say it like
water being in a bucket and is being held back by the gas's pressure around it and the centrifugal force. You got to understand, you sit up here and you waffle in and out. You guys talk about density and relative density, and then you ignore relative density, your own concept, when it comes to other forces besides gravity being at work.
You would have to, with the gas, I would say that you'd have to add the gas after it's at spinning velocity.
That's what these globes run around.
It would then stay in the bucket that's spinning at high velocity, somewhere in excess of 300 meters per second.
It's good to watch these globers trying to change the proof and just, you're claiming it's a globe, you're claiming it's a vacuum. Well, we just want a physical demonstration of that.
Actually, here's something to consider: the gas pressure. When you say it next to, and now I can
really get you on this. So you ignore the gradient and you have a jump in some way from 1 atmosphere to 0 atmosphere, or between 1 atmosphere and 0 atmosphere. There's a jump for you because you say the word next to. And then I thought about your bucket, right? Your bucket example. What you forget is the 1 atmosphere of potential energy in any cubic meter of space, by its nature, will create enough of a counterforce to prevent that water from spewing out when you're spinning the water around.
Lovely story. What you're forgetting,
unlike the air,
you talk too long. It's boring me. I don't care anymore. You're boring me. 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 You're boring me.
We're just speaking.
Boring me.
Yeah. That doesn't matter to me. You being bored. In fact, I'm glad you're one of those students in class that didn't listen. You got bored, and you didn't learn.
You know, I'm a great fan of anyone who wants to destroy the idea of a globe. You know, Baked Beans is back. He's been touted as the next generation who will reveal the truth about reality. Right, Baked Beans?
Who touted him as that?
And if he's your next generation, your entire lineage is dead.
Yeah, what are you trying to do? Some kind of reincarnation? Because it ain't happening here.
No, I mean,
he's doing his cheerleading.
What I'm showing you, highlighting, is that there are people out there who are concerned about that you guys are lying to us, Rocket. You know, you say, like Brummy's saying, you live on a ball, and you don't seem to be able to demonstrate. You don't seem to care what people think, but that's the problem. Is because the next generation is, you know, what will be affected by what you say or do, right, Rocket? If you can't demonstrate it, what do you think they will think? The younger
Kimo, you and I have engaged many times on this. You've been presented with multiple examples, multiple demonstrations, despite your stupid claims to the contrary.
Yeah. You've given me a great explanation. Yeah, you have. You've given me a. Yeah, no doubt. You give me fantastic.
It just shows just how intellectually stupid you are.
No doubt. You've given me fantastic explanations. But you do know, obviously.
And be honest, have you even read any of the papers or anything that me, not everybody else, but just me? Have you ever read any of those?
I mean, I've glanced at them, but you know what I'm like with papers. Is it worth the paper it's written on? I mean, do we have an experiment to back up what was written on the paper? Likelihood is
the papers that I showed you were documentation of the experiment.
But I mean,
physical demonstration.
Who's this child?
We want physical demonstrations. That's what we want. We don't want fucking pictures.
In science, you know how we document experiments? We publish the results.
Of what? Of what experiment?
Of the experiment, observation, the derivation, whatever it is that we're trying to show. The end result is a paper that's, well, ideally, the end result is a paper that's published, or a thesis.
It is peer reviewed.
Yeah, but we don't.
Yeah, there was a guy recently who pushed a finding that he found on his boat, and he put it before us to review, and we debunked him within minutes, and then he admitted that he had lied.
Okay,
but anything you want to you're wrong.
All I'm doing is I'm kind of asking for baked beans here, Rocket. I'm trying to introduce you to one another because you are the professional, you are the expert, and you know, if we're going to ask anyone about,
I don't take that as a global statement. Yeah, there's some areas that I do pretty good in.
Yeah, you're doing pretty good.
I don't care to converse with baked beans. Just he's demonstrated in less than 3 sentences, which is what he said that his argument was, that he has no fucking clue what he's talking about.
Baked beans, do you know what you're talking about?
You know, Kimo, there's this interesting thing that a Danish blacksmith had you demonstrate to every in words earlier
Can't
today.
get debate in this room. Shit.
It's just awful.
Because a moronic dickhead from Birmingham can't listen for more than about 20 seconds without registering with the whole room how bored he is and how it's he needs practical demonstrations, which needs to be asserted at least 6 times so that we all get the message. Apparently, that's the great conversation that Brummy's bringing to the room.
Oh, that's Brummy, you know. Kimo brought the fact that atmospheric pressure is a thing. Very deliberately so, and for an extended period of time. And it was fun because, he admitted it repeatedly. And that didn't take an expert. It took a stupid guy that once put pressure in a container. With a hammer.
Okay.
Chemo. That is all the expert you ever need. You're done at that level. Oh, but I need a guy with a PhD. No, you don't. None of that.
Broomy is a twat. That's the bottom line.
That's Broomy, but yeah.
Baked Beans, have you retired for today? Have you given up? Have you reconsidered your position? Are you now back on the globe? What's going on? Is your microphone working okay?
No, he had to switch over to his Nathan Thompson account on the other server. He'll be back.
Is there a reason why Nathan Thompson would be using an alternate name here? I mean, have we banned him or something?
He got embarrassed yesterday, and he's trying.
Why are you guys obsessed with other flat earthers that are not here right now? We have someone who was able to absolutely annihilate any ideas of a globe, and you're talking about other people. Why is that happening?
Chemo, who was up again, by the way?
This is Baked Beans, okay?
Possible new pressure evidence being posted in the debate chat.
Oh, Preston, what you got here, Preston? You're a bit of an apologist, so not like a real flat earther, you know?
I want to understand how a flat earther can make
you don't want me
an
to
argument.
apologize. I'm posting breaking data, but you don't want me.
You know what that means, Don? That means that there's movement due to convection that keeps and maintains the magnetic field.
Magnetic stuff. Oh, here we go.
There's nothing new there. Most everybody here knows this. That's taken a
Wait before you speak, man.
It is.
Wait and read the next one. Read the next one, Zanuck.
Yep. All right, guys. You guys know how to get rid of me with magnetism. That'll definitely do it.
Again, what is here that we don't know already?
We're just waiting for Baked Beans to fix his
This story came out yesterday that Texas got this paper published or whatever it is. So whatever.
What does it mean, Preston? What's the importance?
Okay.
What's the importance of this paper?
It must have been peer reviewed.
Yeah, the net is, and it says right below it, they discovered that the age of the Earth's core is older than they thought.
Oh, interesting.
Except nobody's ever been there.
They doubled it. They just doubled it again. Or not again, but they again moved it and it's doubled now.
Move the goalpost.
Interval.
Never been to the bottom of the Marianas Trench. Maybe it's still there.
Riveting.
So, can anyone help me understand how that dome does what it does with those gas molecules? It's just perplexing.
Oh yeah, of course. So there's no actual physical barrier. So what happens with gases? Gases tend to find their equilibrium. So depending on the temperature, they may either combine, become dense, fall back to the earth, and cycle back around, or they would just.
You're saying there's no dome.
It's not a solid firmament, as in.
Is there a liquid firmament?
It's just it's a barrier. I mean, obviously we can't go through it.
Barriers are solid.
But I would say that a lot of the particles are like a sponge, absorbed.
How does this barrier work if it's not solid?
What is compositional convection? Flat. What's compositional convection?
Wait a minute, hold on before you try to get me with that.
But you're just having them guessing shit, dude. What the fuck?
Just don't get me muted just yet. Just give me a little bit of time. So, how does a barrier without it being physical?
Well, just think about it like this: when you throw water onto water, it just absorbs into the water. So obviously, as you've got gases, because as I understand, gases are not bouncing balls; they're more like a fluid. So this fluid-like gas, if you want to call it that,
I don't have a lot of time.
all it would do is just
there's like a dome-shaped jet stream of some kind that's cycling around and around and around. that's preventing.
It's just more like a layer, like the belt. You say it's the Van Allen belt, so it's something similar to this, but just more. You could say oval, yes, like dome shape.
So wait a minute. So what you're saying is that the density of air decreases as I go up in altitude, and then there's a sharp increase. There's like a gas gradient next to a high pressure gas zone.
Yeah, so what you've got is because I say
wait.
No, because
so
for
you're
me,
saying you flat earthers are saying that you can't
They're
accept
not all
that there's
flat
a gas
earthers.
gradient next to a vacuum, but you can accept that there's a gas gradient next to a high pressure atmosphere.
no, it's the same pressure from top to bottom, but the pressure just goes out. So it's like it gets vented out. So it doesn't increase inside in here. So we can keep the same. Well, like I said, it goes
Vented
through.
out of what?
Out of like the dome absorbs like a sponge, absorbs all these gases.
Sounding like lemon.
Like a liquid, absorbs the liquid.
Right, but in order for there to be a venting, there has to be a boundary. There has to be a barrier to be vented.
Yeah, but it's called the Van Allen belt.
It's sponge, you moron.
I mean, the Van Allen
Space
belt?
sponge.
The Van Allen. So the Van Allen belt is at a distance that is so far high. Long before you get to that distance, there's space, there's vacuum. So how does that?
No. Before the Van Allen belt, it's all atmosphere. You can't get through the Van Allen belt. That's the area.
Wait. It's all atmosphere. What's the pressure? Just like, let's say 10 meters before you reach the Van Allen belt, what would you say would be the pressure in the atmospheres?
Same as it is down here.
Okay. At the top of Mount Everest, it's not the same as it is down here.
Yeah, same pressure, just colder.
No, it's not. It's not the same pressure, bro. What are you talking about?
Well,
wait. If you're saying the same pressure, you're saying there's no pressure gradient.
How we can demonstrate
there is
this?
no pressure gradient.
How we can demonstrate this? So we can take a bottle that has 90 psi inside the bottle. So we know if we lower the pressure outside of that bottle, the bottle will explode because of all the pressure on the inside, and the cork obviously will reduce in size, and obviously it will explode and pop. So what we have to do is send a champagne bottle up to 100,000 feet, and we should expect to see an explosion because you have high pressure on the inside and low pressure on the outside.
That's not what happens,
bro. No, that's not. Yeah, that's not what happens. But here. Let's make this easier. Let's just use a helium balloon. If the pressure is the same above as below, then why does a helium balloon go up?
Density.
No, you just said that the pressure gradient is the same. There's no pressure gradient.
Yeah, this is
if
to
there's
do.
No pressure
this
gradient,
is
there's no change in density.
This is temperature trying to equalize.
But here's the thing, my friend. The temperature above is colder than the temperature below.
I know,
But
yeah.
you've got the sun energy. The sun's energy, which creates the heat, is above. So that energy, which you acknowledge, heats up the gas.
No.
Right?
You see, the
Gas
sun.
rises.
Hold on. The sun is just a light. You see, and
I'm not talking about the light. I'm talking about,
but the sun's not hot. You see, that's your mistake. That's your first mistake by thinking the sun is hot.
Chemo, they think we have a gradient. Hold on, Flatten. My turn to talk. They think we have a gradient a temperature gradient where it's hot at the surface, then it gets cooler and cooler as it goes up. But then we come to a point where it gets really hot. So they think there's this temperature gradient, but it changes once you get to a certain elevation.
They think, or we know? We can measure this, by the way.
No, we know what happens, Jen. We've sent pressurized items.
What altitude does that? Because see, this is what you're trying to do. You're trying to make it look like there's some weird looking bell curve or some weird looking S curve when it comes to altitude and pressure, altitude and density, altitude and the sun's rays, altitude and refraction, and so on and so forth. I see this newfangled flat Earth argument. So let's crush this now. Where in the world, literally, where in the world do you encounter this gradient changing back?
You guys say there's a gradient changing back. We say it just gets colder as you go up. You're the ones that are saying you hit a certain point and then all of a sudden it becomes
it gets colder as you go up. You have some kind of boundary that prevents the gas from escaping. Oh, I'm sorry, Flat Destruction. Go ahead.
I'm not flat destruction. You ignorant moron.
FFSFD. You got flat destruction in your name. You're
For
good.
fuck's sake, flat destruction. That's my name. Now, Jeremy, you guys say it just gets colder and colder as you go up. What do you base this on, Jeremy?
Well, we observe it getting colder and colder as we go up in altitude.
How far have you observed?
130,000 feet.
Hi, Jeremy. Oh no, that's chemo.
130. We'll go with
chemo.
I've seen the altitude. I've seen that high altitude balloons that read cold temperature still, and then but you guys say they come to a certain point. No, you don't say that.
The limit of your observation.
Excuse me.
That's the limit of your observation, 130,000 feet. And you say it's colder and colder. Can you present that? Can you cite that it just gets colder and colder all the way to 130,000 feet? Can you do that?
No, I have no citations, but you guys do.
Jeremy, I just looked at the graph. Jeremy, look at the graph, learn something, and then come back to us, please.
Hold on, Brummy's my graph guy. Hold on, Brummy there.
Learn anything from the graph. Jeremy is supporting his own claim.
Well, my claim is that it gets colder the higher you get up. We observe that happening on Earth.
Right.
And then, but you guys say...
Chemo?
23 miles. And then it gets colder.
Just listening.
The challenge here is for him to support his claim. Not
Brummy, they got a graph. Go over them with a graph. You're my graph guy.
First, you got to prove you can see that far.
Let's have a look. 1 second.
Jeremy, why don't you look at the graph?
Where is it? What about it?
Jeremy's got information.
My information.
That it just gets colder.
My information is what we observed that. It's hot at the ground level, and then it keeps getting colder and colder as you go up.
Yes. Yeah, what information
is that in contention?
Where is this information?
Is that in contention?
Yes. Yes. Where is this information?
You think it gets hotter as we go up, or what?
Nope. No. We're playing this game. Don't let him turn the table. Jeremy asserted just gets colder and colder. Jeremy, support your assertion. Please.
You try
to be very fair, very polite, and just above board. Jeremy, do it or retract.
Well, I thought it got colder the higher you went up. That's what I've seen on the tops of mountains without snow caps.
Then
Jeremy,
just say
you got to think bigger. You got to think bigger. Through the troposphere, that's true. Then in the stratosphere, it goes up. Then in the mesosphere, it goes down. Then the thermosphere goes back up. This is what
you're saying there's all these temperature gradients all over the place, all willy-nilly.
Yes, the air pressure gradient never varies. That's always getting less and less.
Right.
You can't. You were trying to correlate the air pressure with temperature, and you have failed.
You can't do that.
You do need to retract, my friend.
I wasn't trying to correlate.
You guys haven't retracted anything.
And
hold on.
You failed.
Flat destruction. You can't say shit because you've made mistakes all the time and never retract anything. Secondly,
made mistakes, but
I've never heard of it. I don't care what you guys say. I don't know about.
Let's not make this about me and you. That's over with.
You're a douchebag. You need to learn how to fucking have a conversation.
To the conversation at hand.
Yeah, that's fair. So it gets hotter and...
For fuck's sake, flat destruction, please continue.
All right, move along. So it gets what did you say? It gets colder it gets hotter in what? Say it again. I never heard that.
It gets cold. It gets colder as you get to the top of Mount Everest. Now, just past Mount Everest, it kind of stabilizes. Then, through the stratosphere, it starts warming back up again. And then at the mesosphere, it starts cooling way down. And then in the thermosphere, it starts warming back up again. And there's reasons for this. Very easy to understand scientific reasons that you will never want to listen to.
I'll just listen to you. I'll just literally listen to you. And I can see the yellow line represents the heat. The yellow line represents the heat, and the on the left-hand side represents the distance, the elevation, whatever you. Oh, that's a word I'm looking for.
In the graph, the heating begins much lower than 130,000 feet.
I have a citation. I posted it
I want
in
to
the
make
thing.
this point absolutely clear.
Can I read? Can I read?
No, Jeremy, because you didn't listen to what Zanuck said.
Who deleted
it? Only
it?
applies in the troposphere.
Who deleted my citation?
Nobody, Mom.
I'm posting it again.
So the troposphere goes down cooler, then in the stratosphere it goes up, then in the metasphere it goes down, then it goes real high in the thermosphere again, really high, like really high. So
let me read this real quick.
Okay, according to this graph, it
goes to 130,000 feet.
As you increase in elevation,
where does the airplane?
You don't need to read it to us, man. We can all read.
How far does the airplane go up? In kilometers? So it's 20, is it?
So we're increasing in elevation.
I have a funny.
Less air above you.
It's going to be about
the pressure decreases.
How many miles? Fucking, I can't be asked. This is why it's shit in here because no one answers questions.
Why is anybody else even talking right now? Jeremy, read your goddamn citation.
Jeremy, I'll deal with it. Throw me.
Who keeps deleting my citation from the chat?
Nobody. It's still there, Mom.
I can't see it. Hold on.
Just called it a dog.
But how about before you go to your citation, you actually address the graphs, and then we can go to your citation instead of just fucking trying to flirt your way out of it.
Well, I have. Okay, as you increase in elevation, there's less air above you, thus the pressure decreases. This is the pressure gradient that you guys say definitely exists. As the pressure decreases, air molecules spread out further, and the temperature decreases.
And then it gets higher again.
And then so we have a gradient of high pressure to low pressure to high pressure?
No, the pressure has nothing to do with it. The pressure is continuing in a downward gradient.
The pressure has nothing to do with the temperature.
It has something to do with it, but not in an atmosphere.
It's not a correlation. It's not a 1-to-1 correlation. So can we read a citation now?
Does he understand?
Jeremy doesn't even understand that this alleged citation does not even address the issue. It does not support his claim. Jeremy, in all seriousness, bro, what the fuck are you smoking?
It's called open snow.
I just got a little bit of a cold. What's up?
He smoked snow.
Jeremy, what you posted has nothing to do with supporting your claim.
It clearly says how it supports my claim.
It doesn't.
Your link is referring to skiers who don't go higher than any mountain on this planet to ski.
Yeah.
There's the actual page where Jeremy got that from.
Open snow.
Jeremy, you're lucky because if you were a little more educated on this, you'd be thoroughly embarrassed.
Listen, I'm at work right now. I got that on the fly. I don't have a lot of time to be looking shit up while I'm working.
It's not time that you're lacking. It's know-how.
Time.
It's understanding.
No, it's know-how. It's know-how. But there's another nice graph up there if you want to see how pressure works. It shows you the pressure, and right next to the temperature graph. The two are virtually not linked. Pressure just drops as you go up. Temperature varies.
So, Chemo, that your distraction failed. So, as you can see that you cannot explain your dome venting anymore. That went out the window. That literally went out the window. So, what you got, bro? Why does the temperature not correspond, and why is it colder near Mount Everest than it is near the surface of the Earth when we know that heat rises?
Yeah, like I was trying to explain, what the sun heats the water in the atmosphere, and because there's less water, where obviously above the clouds, and there's no clouds at 130,000 feet, there's no need for the sun to heat that area up. So the sun's not like a burning ball of fire, or all it does is an intense light that interacts with the water in the atmosphere, given the temperatures,
that's
the
not
seasons.
what causes the air to warm at all. You're just making things up again, Chemo.
Yeah, you're doing a lemon. So, and you didn't even answer my question, bro, because we know that the sun heats more than just water.
Yeah, the liquid in the atmosphere.
No, that's not what heats the air up. There's no water in the thermosphere, yet the air gets very, very hot.
No, above 130,000 feet, the temperature. There is no temp. How do you read temperature? With what?
Wait a second, Chemo. Where does the heat come
thermometer?
from? No. Where does the heat come from, Chemo?
The heat comes from the light source in the sky.
What's that light source? What do we call that light source?
We call that the sun.
Okay, so you have, as you get closer to the sun, the same amount of area that's measured will give more heat, right?
No. There's no water that high up.
I didn't say anything about water. Listen closely. Everything is heated, not just water. Come on now. So an area, if you place an area that is facing the sun, right?
Danny,
and
quit the noise.
Oh, come on, man, come on. So you have that area. You measure the amount of heat, right? That the area is getting, right? And then you move that area closer. Let's say it's like a piece of paper, 8.5 by 11, and you move it closer to the sun. Your flat Earth sun. By the way, I'll play flat earther for a moment. You have to agree that the amount of heat that paper is getting will increase throughout the same measure of time.
Chemo, 45-second time in.
I apologize.
Another clock.
I apologize.
Especially when this douchebag is talking.
Oh, fuck you. You got the apology and you kept going.
I still don't see what the problem is there, flattened.
The problem is, oh God, dude, seriously? So it's colder higher up. It's at the tops of Mount Everest. It's cold.
Yeah, very cold.
More heat per square mile, and you've got your local sun that's much closer, so that the intensity of that heat is now magnified per meter as you get closer. You know, meter by meter, you get closer to the sun, the rate of increase is much greater.
Yeah. So, can you tell me how the sun's on fire inside a vacuum?
No, because
It's
I'm not
on fire.
Our conversation.
Yeah, nitrogen, fusion. Yeah, fusion on itself, and it's not really fire.
Mute Brummy for his own protection. He's saying really stupid things. Mute him.
Well, you guys think getting on fire when it is.
I'll lower your volume, Brummy.
So are you saying that we've got high pressure, low pressure, and then a layer of high pressure?
Nope. Pressure goes down. Pressure goes down the whole way up.
No, bro.
Chemo, the graph is just perfect for you. Pressure is just a straight line.
Exactly what was said.
Millibars to about 80.
He did that deliberately, knowing that is not what was said.
And we caught him instantly.
Entertaining him.
Yeah, Chemo, address the graph that's here, because the temperature changes, but the pressure doesn't.
Yeah, that's impossible without the.
But it's measured and observable. So I mean, what's your problem?
I've just told you. If you take your barometer that's measuring the pressure here on the ground, and as you go up 130,000 feet and below -50, your device will freeze, will contract because of the metals, and you will have no reading. So if you go any higher where you think it's warmer, how will you get a reading if your device is broken?
Because pressure and heat do not correlate in this discussion.
You think you measure temperature?
Well, okay, Chemo, I'm going to give that to you. I'm going to just say that for the sake of argument that a mercury barometer is the only kind of barometer in the world. When you get up to 50 kilometers, the mercury barometer starts working again, and because it's hotter, and it still shows lower pressure. So it's actually hotter at, it's hotter at 60,000 kilometers than at 10,000.
Do you know how they measure temperature in the atmosphere, Chemo?
With a thermometer.
You think they have a little mercury barometer that you stuck up your butt and they're going to measure the temperature with that? Is that how you think they do it? Really?
A thermometer. So we're testing the heat, Sonic.
What about infrared thermometer?
Or a thermocouple.
Where you go? I need a Brummy meter.
It doesn't work if there's no atmosphere.
Yes, it does. It works very well, actually.
You showed us that, Chemo, in the vacuum chamber. You showed us thermometers work.
Thermometers working. Yeah, it's not a full vacuum. We don't have a full vacuum.
No, there's not a full vacuum anywhere we're discussing right now.
We're not looking at full vacuum in the atmosphere, are we?
Yeah, there is always atmosphere until you reach the Van Allen belt, the biblical firmament, and for the rest of you, the dome.
Okay, 50,000 feet, you have like next to no air pressure. It's really low. I'm sorry, 50,000 kilometers. And the temperature's higher. This goes against your stupid little argument. Of course, so would the elevator test, but you won't do that.
What this cartoon goes against is practical demonstration of a champagne bottle.
The practical demonstration is a balloon that went up and they measured these at those points.
Your body only pumps your blood at 2.5 psi. When you go up a mountain, you tell us that your ears pop, and you only have 2.5 psi in your body. So, if you had 90... Mike, you're not letting me finish, making me shout. So, if you had 90 psi in your body, that much pressure, and then you went to a region where the pressure was lower, you would explode. So, if we take a champagne bottle with a cork, which we can demonstrate that reduces in size in the vacuum, when we take it up to 130,000 feet, it doesn't explode. The pressure is the same. It's just colder. This is not a graph or data. This is what you can see, test, and demonstrate. Got it on the big screen.
Measured.
I've got it on the big screen now as we're talking. I'm looking at the champagne bottle, looking at the altitude, height, and there was no explosion.
Yeah, well, that really comes down to the strength of the bottle.
There was 90 psi inside.
You can have 100 psi in something. If I take a metal pipe and I put 1,000 psi in it, I could put 10,000 psi in a pipe. It really depends on the strength of your system.
So
why does the balloon burst and not the champagne bottle?
The balloon bursts because the exterior of the balloon became brittle and it shattered.
Why didn't the exterior of the bottle become brittle and shatter?
Exterior of the bottle. It froze.
What? Yes. The bottle is cold. Why didn't it freeze and shatter?
Because the internal liquid froze, became a solid, giving no more pressure.
That would shatter the bottle.
Because it's not giving any more pressure. The inside.
No, that would shatter the bottle. If you freeze a liquid inside a bottle, it'll shatter.
Yeah, so it's all become one. It's frozen, so all equalised with the outside.
That's not how it works.
The inside and the outside equalise, therefore no more pressure.
Put a champagne bottle in your freezer.
Why did the inside and the outside of the balloon equalize? Why didn't the balloon equalize pressure?
No, they equalize in temp. They tried to equalize in temperature.
Right, but why did the
curiosity
matter? I'm sorry,
a really short question that I wanted to add. At how low a pressure did you have the champagne bottle burst in a vacuum chamber?
The champagne bottles are 90 psi.
That's inside.
That was inside. That's inside the bottle. But when did it burst in the vacuum chamber?
When does it burst in the? It doesn't burst in the vacuum.
In the vacuum chamber, you said it burst in the vacuum chamber. That was your claim.
No, the cork reduced. The cork, not the bottle.
Oh yeah.
Cork of the.
He's talking how corks shrink when you reestablish pressure, and the pressure differential between inside the cork and the outside the cork changes.
So we should have two effects. The cork should reduce and the bottle should explode.
No, actually, it wouldn't have that.
Explode in the vacuum chamber. Do you have the bottle explode in the vacuum chamber or not?
Yeah, if you put a can or a bottle with high pressure inside and it's low pressure outside, yes, it will explode.
Did you do that with a champagne bottle? The vacuum chamber.
I didn't do it.
Exploded.
That'd be very dangerous. No, I didn't do it.
Not really.
Did you show a film of it happening?
No.
Oh, no. So you have no evidence that a champagne bottle will actually explode in a vacuum?
No.
Fair enough. No. I'll go with that.
Okay.
But then you cannot expect it to explode at altitude, right?
No, but we can expect the cork to reduce in size.
That's when it gets into pressure, right?
We expect all the air out of the cork to be sucked out because there's low pressure. All the air in the cork should be trying to fill the space if there is low pressure.
That'll make the cork bigger.
But as we can see, there's no need to fill the space because there's already air around it. It doesn't need to
Timo,
go and try and fill it.
Did you see my balloon thing? I showed it to you, not balloon, the marshmallow thing. As you pull a vacuum, the marshmallow gets bigger.
So I just want to explain to Sort that
what would happen with that cork in the bottle is it would get bigger.
How air works, right?
Or it tried to, but it'd be up against glass, so it couldn't get any bigger.
Tries to fill the space, Sort. So all the air in that cork, when it left Earth, has air in it. You take it to a lower pressure region, the air in the cork will try to fill the space, therefore reducing in size.
Thereby expanding the size of the cork.
Therefore,
eventually equalizing, and so there's less air in the cork. Yes. Then you bring it back down, but at what speed? And most importantly, how low was the pressure at the time when it was in the vacuum chamber for it to do that? How low was that pressure in the vacuum chamber?
Zero.
How long?
Zero.
Actual zero. Well, approximately zero. You see, the globe model tells us at 130,000 feet, we will have a pressure of 0.16-ish atmospheres. That is not nearly zero. That is a shitload more than zero. That is like the vacuum you can make with a bicycle pump.
Yeah.
Yeah. So you do not have a comparable vacuum, do you?
I would say so, yeah.
Well, I would say you don't.
Okay.
Since you provide no measurement of either, then what you got.
Okay. It's not comparable. I agree. It's not comparable. Up there is not as low as in the contained vacuum. Right.
Because
I agree.
The globe model tells that you'd have to go higher to get it that low. You have to go near the common line.
Precisely, yeah. You'd have to go 130,000 feet. There was still atmosphere, and there was still it's normal pressure. Got to go higher.
No, normal pressure, but less than the surface pressure, but not at the level you could get in the vacuum chamber, because the vacuum chamber will go maybe not to zero, but fairly far down, right?
I get it. You got to go higher. Yes.
Yes.
Yes. There you go.
Faster. Higher and faster.
Higher and faster. Yes.
100. Yeah, because you have that shrinking of the cork is going to be caused by the engine pressure being pretty fast.
Yeah, that makes sense. Yeah.
Yeah, and we know, as per our reality, that the common line at 100 kilometers is about 100,000 of the pressure at the surface, and that is where wings do no longer work. And, that would make a proper vacuum. So go up 100 kilometers. Do that. See what happens.
Maybe we should go 200,000 feet. Yeah.
Well, 200,000 feet is not 100 kilometers. You need about 4.
Maybe we should go where the ISS is, right?
Oh,
then we will know.
The common line will do fine.
Good idea. Yeah. If we send a champagne bottle to the ISS, we'll see if it really explodes or not. Yeah.
Oh, if you did that, strapped it to the outside of the rocket and took it there, and they got it, and nice, they brought us champagne and took it inside. Yeah, that would exactly happen. But this seems a bit of a hefty prank, doesn't it?
Of course.
Rumi, explain to me again, why does it matter if the champagne bottle explodes or not to you?
Because there is an immense pressure from within. Now remember, we have 2.5 worth of pressure pressing from the inside of our bodies, and we're supposed to feel the effects going up a mountain.
And again, I say stop that, Chemo.
We're supposed to feel the effects. We're supposed to feel the effects in an aeroplane at 30,000 feet. And we only have 2.5 worth of pressure. Can you imagine if we increase the pressure in our bodies to 5 psi, 10 psi, we would explode going up a mountain. So that bottle.
Emo,
that has
why is it that it matters again? What's the short version?
If I took a tire with 30 psi, it would explode. Okay?
He's lost it. All right, got it. You don't have coherency right now.
The tires on my bike hold 60 psi. Jesus Christ.
I think you have a problem calculating. This is where you guys need maths or numbers. You guys are usually good at this stuff. So you got to figure out there is 90. There is 90 psi inside, and there is 0 pressure outside. What's the differential?
Forget about surface area and the tensile strength of the container, Chemo.
What should the pressure inside try to do if there was less pressure outside?
Depends on the tensile strength and the surface area, Chemo.
Yeah, but what should happen? What would we see happening?
Chemo, where did you get this 2.5 psi in our bodies?
That's how much our heart pumps the blood around the body.
Blood pressure reading.
That's our blood pressure in our veins.
Yeah, that's all the pressure we have inside our bodies.
The veins have a very small surface area.
Yeah, that's
there's no other pressure in the body.
Yeah.
That's it.
That's it.
Chemo wins.
So yes, our arteries are under pressure. 2.5 psi, you said?
Yeah, around that. I think it's like between 1.9 and 2.5. But, that's like maybe the limit. But you can Google that just to get your double check-ins and things there. But the idea is that the only pressure from within the body is the heart pumping the blood. Now, remember, if you go into a region where it's lower pressure up a mountain, your ears are supposed to pop because you say it's lower outside and higher inside.
Protect your inner ear. Yes, that's what happens.
That's just the old wives' tale, right? But the reality is...
No, you can actually show evidence for it. Go ahead.
The reality is that not everybody's ears pop. Ears pop due to health conditions. You can have people here on Earth.
Why are you ignoring the tensile strength of the container?
No, I've got a video where we've got a program called This Morning. This lady, her ears were just popping constantly, and she didn't know why. Speaking to the doctor.
What's the PSI in your lungs when you exhale?
When you the PSI,
you can build artificial pressure yourself.
Well, you would curved. You'd have to look at the size of the lungs, the container. Yes.
How do you exhale air with lower pressure?
No. The air inside your lungs, the container. Everyone has different sized lungs, right? Different containers.
The point is, again, I'm going to ask you point blank. How do you exhale lower pressure air into higher pressure in the atmosphere?
What? I don't understand.
You got him. Ooh, good one.
Say it again.
How do you exhale lower pressure air from your lungs into the atmosphere that's at higher pressure?
Because of the force that you create.
The force creates a higher pressure, you ignorant fuck.
No, you've created enough force to combat whatever you think is pressing on you.
That's the point.
What do you want to lose next? Go to the next topic.
So again, another way to understand that there's no atmospheric pressure is that when you go swimming, and if you were to drown, and then you need resuscitating, so they take you out of the water, and then you're on the floor, they have to blow into your mouth or press on your chest. And if the atmosphere was really pressing, they would just open your mouth, the atmosphere would just go in and give you air. You see?
No, what happens? No. Here's the thing. What happens is when you're pressing, okay, your body, the tensile strength of your lungs and whatnot, it doesn't go away just because you're drowned.
What kind of brain defect do we have to have to actually listen to this?
Right, you're pressing.
I know he's paying for this. And what you do with your days to do that.
Dude, chill. There's a pressure differential, and that pressure differential allows the air to enter your lungs when you release the pressure.
Okay.
Don't worry about my voice. Just worry about what's being said.
Got you. So what you guys, you really don't have any practical demonstrations to show that the atmosphere is pressurized. We can show that it's has a temperature, gets colder, and obviously you would need a container for that pressure, which obviously I've told you there is no container, there is no force, so therefore you can't have this pressure that you guys allude to. See? Therefore, no gravity either. Yeah, gravity.
We have the acceleration, Chemo, and I explained it to you, and you did not refute it properly. Also, we have that balloon expanding as it goes from the surface to the 130,000 feet. So we have ample demonstration of the pressure and the gradient.
Gradient. You've got a temperature gradient. If you want to say there's a gradient. It just gets colder as you go up. That's it. The pressure would be the same. Water is everywhere.
Just went through this, bro.
Right. Oh, so the material inside the balloon gets cold and expands because it's cold.
No. So you've got this gas, warm gas, or you've got this gas pressing, which is creating the temperature.
Chemo, take my advice. Move on to something you can win. You're losing at every turn.
Do you want us to move on to something you can understand?
Chemo, if I were to use some cold,
You want a little bit easier curve so you can understand.
Anyone who's
I want you to have a W. I want you to walk away with a W before the day's over.
Chemo, could I use cold helium? Helium that's been chilled to a lower temperature than the temperature at.
No, it's not the fact that the helium itself is given the temperature. It's the pressing against the wall that is given the temp. Yeah, the walls of the balloon. Yeah, so as it presses.
I just want to point something out, Chemo. I want to point something out. What's quite convenient about this, right, is that it gets cold when you go up to about the airplane level, where most humans are going to occupy it, so it gets cold there. But then when it goes outside the area where the humans go, apparently it gets really warm, but then it goes really cold again. But you know, when that guy done the space jump for the what's it called? Red Bull gives you wings. Yeah, he done a space jump. He was about 70 miles in the air, or 80 kilometers or something, and that's basically where it gets cold again. So everywhere humans ever been, they experience cold, but this metasphere and stratosphere area where it gets warm, you know, it's not very an occupied area for humans. How do they know it's warm there?
It's not
warm. Who's ever filled a weather balloon? That is what you did to do that whole, bottle and high altitude thing. They know you fill it to about a third because it's going to expand.
Mm-hmm.
You fill it completely, is going to blow up before it gets anywhere.
Yeah.
So it expands, because the lesser pressure outside is not holding that volume in.
Yeah. So like what the creator did, it's colder like to the left, to the right as you go up. So you can't escape. Obviously, you can't go down. Different region, but it's just cold all around, and there's like a warm region in the center, like a warm area where the sun obviously heats up the particles. And
particle balloon is heated, so it's essentially a hot air balloon.
Like I said, the gas is not the heat; it's the pressing against the walls of the balloon, which creates the pressure, which increases the heat. Which, of course, the exterior of the balloon is getting colder and more brittle, weaker, which breaks the balloon as the inside is being pressed on. It's not that difficult.
You're saying increased pressure creates heat?
No. So let's say you're inside a giant balloon pressing against the walls. So it's you that's you that's hot. It's your hands on the wall. As you press, you create that heat. As you press on the wall.
Yeah, but that doesn't create enough heat to.
Yeah, but it does. If the outside is.
Chemo. Listen, you can measure the heat, the temperature of the wall of a balloon at any altitude. You are not going to see a great difference.
But again, when you have pressure, you have an increase in temperature. So
not that dramatic.
Yeah, so when you've got the gas pressing on the walls, as the walls are becoming weaker, and then the inside is pressing, of course it's going to explode.
No,
Chemo, look at this picture. Look at this picture I just uploaded, yeah?
Yeah.
Right, so 10 miles up, that's where airplanes are, where humans, are on regular travel, and they can tell it's cold outside of an airplane. Yeah? Then we go up out the ozone maximum, right? And then it starts to heat up, but no humans really experience this part of the stratosphere or the stratopores, and then the metasphere. But the metasphere is where that guy done the jump. You know that jump? What's it called? The Red Bull wing jump. He's about 70 kilometers off.
Brummy, how high was he when he fucking jumped?
About 80 miles. So it's about 78. What?
Try again. Dude, do some fucking research before you start running that ignorant mouth of yours.
Oh, it's 62 miles. 62 miles up.
4 miles, about 24 miles.
62 miles, we've done the space jump.
About 24 miles, you ignorant fuck.
No, it says here, space jump height, officials, the skydive space jump, on mission up to the edge of space, officially recognized the border. Actually, however, experts generally regard the space begin at 62 miles, 100 kilometers there.
Fucking cut.
The record holder is Alan Eustace at 41 kilometers, which is about 20-something miles, 26, 27 miles.
It says here, 62 miles.
Shut up.
It does?
It says here, I don't know how to read.
I'm telling you, Robbie can't read.
World's highest jump, 62 miles. I'm reading it right now.
No, you're not. No, you're not.
Yeah, I am. Yeah, I am.
Post
show us the link, bro. Just show us
posting
the link.
it. Posting it.
So we can humiliate you. You've asked for it.
I don't give a shit.
An Austrian daredevil plummeted to the record books today, October 14th, breaking the mark for highest ever dive out of after leaping from a balloon more than 24 miles above the Earth's surface. So what are you reading?
This is a complete different link. The link's changed.
I just clicked. Oh, the link changed, guys.
Oh, we were supposed to know that.
This is some pretty shit. Game over, guys. Wow, the link broke, man. I gotta keep that one. Broomy, can I use that one on my next debate with you guys?
Good to know. Good to know Brummy can't read.
Says it here, look, project officials traded skydive space jump, calling it the mission to the edge of space. The official recognized space border is actually higher. However, most experts generally regard space as being an altitude of 62 miles.
Yeah.
That's where space begins.
And where's the
not
jump?
Where you jump from. The jump is 26 miles away.
Oh, okay. Are we done? You pretty much stepped into it.
No, I read the wrong bit. That's the bit I read when it said 62 miles.
Yeah.
You know, there's a pattern here, Brummy. What just happened right there happened.
Oh my God, he's made a mistake.
The pattern is you're always wrong. It's very simple.
You need to learn to admit you're wrong, me.
Oh, sorry. Yeah, I'll probably admit when I'm wrong. I can do that. You can't.
Well, let's see you do it right now.
I already did.
Did we? I missed it. I apologize. The whole room heard
No
it.
worries. Don't worry, man. Don't worry. Good. You let me know when you want to apologize for fucking trying to conflate situations and not listening to people when they explain identity.
The room doesn't.
You can always look at that video. You're welcome to look at the video and review yourself.
We don't want to go into the bullshit.
You're welcome to watch the video.
Trying to complete 24 miles with 80 miles. Is down.
Yeah. I read the wrong thing. The thing said it at 62 miles, didn't it? So I just read the wrong part.
Regardless of whether you're an idiot or not, Brummy, you're typically wrong.
All right, I've made something wrong once. Well done, lads. Continue.
You can stop this at any time, Brummy.
True.
Everyone makes a mistake, mate. It's not a fucking end of the world, is it?
Yeah, no, but it's your life.
And even this guy, where that guy jumps out, it's still practically cold. Everywhere the humans have been, even it's still consistent. Anyway, it's just if we can go up there, we can probably confirm it ourselves. So
we can't send a balloon up. You have to stick your finger out into the.
We could, yes. Send a balloon up there, then send a balloon up there, put a little temperature gauge on it, and then see what the temperature.
That's what that graph was all about. It's about balloons they've sent up to measure.
Aren't you flat earthers the one that satellites?
Do it independently, can't we? We can do it independently. Test if they're saying that's true.
Satellites are just on weather balloons, Broomy, right?
Huh?
The satellites, they're on weather balloons, aren't they? They're attached to weather balloons, right?
What?
Okay, yeah. Just like you can't read, you can't hear.
What?
Yep.
Say again.
I defer to you, my friend.
Huh?
So what was that?
Yeah, I was wrong about a fucking height. Well done, lads. Continue while you're stopping talking. You might as carry on.
The destruction has been complete.
And that's it. Oh, look, Brum is wrong about a height jump. Therefore, what?
You know,
therefore what?
we can just
Therefore
go
what?
often wrong.
Therefore what?
Therefore nothing.
Often wrong.
Therefore nothing. I read an article wrong. I missed mistake it. Missed my mistake. At least I've got more dignity than a lot of you lot, because you don't admit when you're wrong. What you do is you go, I just go, yeah, all right, cool.
Right.
Show me gas pressure in that container. Show me gas pressure in that container. Show me a gas pressure in that container.
Or he'll keep mentioning it over and over again as if that.
Go outside and look up.
I know. Yeah, as if that's the crushing point. Oh, look, Brummy was wrong about jumping from 62 miles to 24. Wow.
Hey, it's only a factor of 2.
It's only like misinterpreting, reading the wrong part.
What was the point with the height, Brummy? What point were you trying to make?
Yeah, I just thought like everywhere the humans have been, it just seems to be cold. It seems to that matosphere, stratosphere.
Well, at the height that we've had balloons and weather balloons go to about 53 miles. They show temperatures climbing.
All right, I need to look at that. I need to see this stuff.
Right. That's why videos of it? Satellites. So you got your satellites that you say are on balloons, and what you should have been done by now is recognize those readings.
Should have been done.
Weather balloons, how high?
53 miles is the record.
For real?
Yeah.
So someone can send one of them balloons up in here, put a temperature gauge on it, and see if this is consistent with the data they were giving us.
That's why they're called weather.
Who's done this?
They're called weather balloons. They already have that.
They just have P900s and they take pictures of the weather. That's what they do, Bunny.
Right. Oh, gee, they're weather balloons. They should have a temperature on them and a barometer. Yeah, that's a great idea.
Good job, man. You should be a scientist.
Thank you.
Yeah.
So 5th grade project last year, I posted some graphs in there. These are 5th graders who are measuring time versus temperature and time versus altitude.
Celsius. I've never heard them say that though.
Who the fuck is talking?
You are.
Thanks.
You said it was a 5th grade project?
Yeah, 5th grade weather balloon project. Here they have a barometer and an altimeter on it. The data is right there in chat, so you can see how time versus temperature and time versus altitude. I'll put pressure on there as well. But these are 5th graders, dude.
So
I know you dropped out right around 5th grade.
I mean, in that 5th grade experiment, did it show that it got to 1,500 degrees Celsius in the thermosphere?
Did it go up to the thermosphere? Did I ever claim
like,
that?
what are we talking about here? Exactly, because somebody was like, yeah, it gets cold when you go up, but it does. But then it gets warmer again when you go up even further. But I don't know if that's where the conversation was going. I came in through the middle of it here, and I'm trying to figure it out.
I mean, that's partly because Chemo asserts that pressure is directly correlated to temperature. And since the pressure drops off at a very even rate going up, and temperature varies pretty wildly, pressure is not the driving force of air pressure at the atmospheric pressure.
Right, but to air temperature though is, I think, once we get up into the thermosphere, are we talking about air temperature anymore, or are we talking about actual thermal temperature from radiation from the sun approaching an atom?
Oh, yeah, I can't say that, but I'd say that where we're talking about, where the temperature starts to rise, is still in the well measurable zone with balloons and thermometers.
And that I think we should all be able to agree on.
Hey, this is pretty interesting. Somehow I muted Virus and Reasons, but I didn't touch the computer. Is there some kind of way to manipulate the system here to do that?
Well, if they're not worth talking to, they just get auto-muted.
Wow.
Right.
Actually, Flatten, turn your computer off, wait 10 minutes, then turn it back on.
Oh,
that's just ruthless.
Come on, Rocket, man.
No, it's been proven that an hour at least. That works best.
Oh, guys, I've been good.
Time.
That's
like
you take 1 cup of water, minutes. You mix 2 tablespoons of salt in water and pour it through the top of your computer.
130 minutes seems to be the highest point. The highest point, the temperature. Let's have a look at the temperature. 130. Back there, isn't it? The temperature don't really change that much. It's warm, goes down to cold, goes slightly a bit warm again, then drops down to cold. The reason that temperature then shoots down so cold is because obviously it's falling, right? So as it's falling, the wind's causing a lot of cold air as it's falling.
Actually, wind doesn't make things colder.
Sorry?
Wind doesn't make things colder.
Well, you know what I mean? As it's dropping down, there's like wind going up, it's causing fucking air going back. It's cooling it down.
Wind doesn't make things colder.
All right, wind doesn't
unless they're wet.
Don't give a shit about your pedantic bullshit. Don't care about your pedantic bullshit.
It's not pedantic. It's very specific.
It is pedantic. The balloon obviously pops around. Looking at this data here, the balloon pops around about 130 minutes. It pops, and that's where it gets to the lowest point, where the temperature seems to start rising. Then as it declines, coming down, all the temperatures change and all the altitudes change. So it's obviously something to do with the balloon dropping.
Chemo. The temperature drops as you go up to that altitude. And if I recall, gas compresses at lower temperatures. And what was your argument again about the walls of that balloon?
His name's Brummy, though.
Something's pressing up against the walls of the balloon. What happens? Chemo, Brummy, they're all the same to me now.
Okay.
Oh my God, those balloons pop when the temperature is almost at the ground level temperature. How weird is that?
Well, I'm just reading the data, and you sent us data. I'm looking at it, and I'm just made an assumption from what I'm seeing. Obviously, at 130 minutes in, the temperature seems to drop, and obviously the altitude then drops as well. So obviously it's coming down, isn't it? And the pressure seems to go up as well. So the pressure goes up, so obviously it's going down. Obviously the balloon's falling down at that point, and when it goes to minus 40, then obviously that's because of the fucking wind that's going past it and cooling it down.
That's the highest point.
Oh, wind don't cool things down.
That's the highest point. Is at negative 40 degrees.
So is he saying that
that's the 77,000 feet is negative 40 degrees, and then it starts falling, and that's when the temperature starts going back up.
Yeah. That's what I'm saying.
Well, the temperature going back up has nothing to do with wind.
Well, the temperature goes down. It goes negative
because
40
it was going higher. Has nothing to do with wind.
So if it's going, why does the altitude go down then? At time on the time one, it says it goes to 1 minute 120, 130. Then the altitude then starts declining. And that goes exactly when the temperature starts to decline as well. So I think you're wrong. The altitude goes down on that graph, and the temperature goes down exactly at the same time. The time 130, about 130, the altitude and the time starts to decrease, and the pressure also goes up as well. So obviously, if the pressure goes up, obviously the balloon must be declining because the pressure goes up, the temperature goes down, obviously with the wind hitting it, and fucking altitude is obviously going down as well. So I don't know what you. I think you've read the graph, your own fifth grader graph's wrong yourself. No. Yes. Time for you to admit that you're wrong. It's all right, though. I don't expect you to be a man and say, "Oh, I slightly got a bit wrong."
Is he actually saying that your graph is wrong?
No, he read his own graph wrong to me. He's trying to tell me
that was Brummy actually saying that your graph is wrong, Kazo.
No, I'm telling him he read the graph to me wrong.
Interpretation of it.
No, you got it wrong to me. You got it all recorded. Go back and listen to what you just said.
What happens
you said the coldest. You said the coldest point. You said the coldest point was the altitude. You said the negative 40 was the altitude, and it wasn't. Clearly, it wasn't.
Fifth grade class bored, so he stopped paying attention.
No, he fucked up on his own. But you know what? That's the thing. Don't expect you to admit when you're wrong because you're a Glover. He's going
to be quiet about it. He's not going to admit to it. So that's okay.
Exactly. Yeah, little faggots, man. Little faggots.
Little
what? Look. Oh, you got something wrong. Look. Hey, you got something wrong. Fifth grader graphs. Fifth grader graphs. Fifth graders. Yeah. Oh, it's fifth grader stuff, man. And you couldn't even read it yourself.
Like, well, you're the one who's failing to read it, bro.
Hey, fifth graders! This is fifth graders, man. Hey,
he's trying to claim victory with dropping.
Like it wouldn't have been a big deal. It's not even a victory, but you did miss.
Hey! Hey! You guys are never admit when you're wrong. You got too much pride. Admit you're wrong. Admit it.
That's the only reason why it's a big deal.
Admit you're wrong. Go on.
So I have a question.
You're wrong. Then do it for us all.
Hey, I know her. Just do it.
You're wrong.
I have a question about earlier.
That's how you were being to him. You literally were saying, "Well, then do it now."
Someone talking.
Let's hear it. Let's hear you apologize. Come on. Say you were wrong, man.
Question about earlier.
No. Let's not change the subject. Let's talk about
when Kimo was saying that temperature. Sorry.
Let's change the subject.
Does not cause temperature. What did he mean by that?
You got no respect. You guys are fraud.
Oops.
Can't take it, can you? You ain't man enough to admit it. Admit you're wrong.
Different when the whole room was.
Who are you talking to, Brumi?
Him.
I know.
The only
now the shoes on the other foot.
Yeah.
Can't even read his own fifth grader fucking grasp properly. Got fucking altitude confused.
To themselves.
Yeah. Fucking idiots.
Myself.
Brummy, why don't you stop talking and let him explain?
Nah.
I don't know what his question is.
GG, good game.
I mean, this graph doesn't even make sense to me because the temperature should go much lower.
He thought the temperature drop was the altitude. Fucking spastic. Fifth grader fucking graphs. You can't even read your own shit.
I never said that.
You can't even read your own shit.
Yeah, since I never said that, I guess you can just claim whatever victory you want. That's okay.
Yeah, you did. You literally said.
Hey, I said that the temperature was the altitude.
Go to the stream. Get the recording. Right. The guy said the coldest point was that where the highest point. Where is that the highest point?
Yeah, this is a complete waste of time with Brummy.
Yeah, just apologize, man. Apologize. Apologize
to who? To you and your white
Brumi, or else Brumi will not talk to you.
Grim.
Apologize, bitch.
I'm not apologizing.
Literally, make a little teaspoon of your own medicine.
This is too funny.
All right, Brummy, you could shut the fuck up for a moment and like let
Yeah, but he could
talk. You don't have to just babble.
He could apologize. He could just apologize. You could just apologize.
Why not? I'd like to know more about this graph because it's.
No, man, just apologize.
Because no, shut up, Brummy. Does anybody know about this graph? Whose graph is it?
Mine.
Yours. Okay. Why does the temperature seem to remain so high at those altitudes?
See the hypocritical bullshit, dude?
Good question. This is just what was recorded, just direct data.
I'm wondering if there's a problem with the box actually producing heat, radiant heat.
It might have, since it was an insulated box for the equipment.
I guess that doesn't make
because that just simply doesn't make sense. So Brummy might be right in a sense that once the air started flying over, it blew into the box and
thank you.
Was actually experiencing the actual temperature outside.
Thank you.
It might have.
Thank you. It's appreciated. It might have.
Brummy, but you see, I'm actually going from a logical standpoint, and you're just acting like a fucking hyena.
He's trying so hard to claim victory. It's so retarded to try to talk to this Hmong.
And you are being a Hmong. And so we all know that the temperature at 75,000 feet should not be 40 degrees Fahrenheit or 50 degrees Fahrenheit. So there's something unusual about this data.
It's possible that the altitude wasn't measured properly. There might have been a compressed. The values were compressed somewhat, right?
Don't know. I just find it unusual.
That's a possibility. The temperature readings could have been correct if the altitude readings might have been incorrect, and that would fit.
Cosmo, you got a link to where this came from, so we can see what the fuck they were doing, what they were trying to test.
Like I said, it was just fifth graders. They were just recording data as the balloon. They built the balloon.
Fifth graders
built the system, and then launched it and gathered data.
Yeah,
that was it.
Where can we read more about this?
I'll see if the raw data is still available. This was last spring.
Was this a project that you were involved in, or
I was loosely involved with. My kids were involved in it. I mean, it's stuff that's so accessible and easy that I'm surprised that, flat earthers, if they have questions about this kind of stuff, you can build this on your own and call your local air traffic control and tell them when you're launching and go ahead and collect your own data.
Accessible and easy if you're in school. These idiots dropped out of kindergarten, probably.
Well, I know Brummy dropped out around 5th grade, but...
Hey, is it possible? What's the highest that we could get a balloon with a camera on it to get visuals of the Earth? I mean,
173,000 is the record for any type of balloon that I can find.
Well, here's the second part of my question. Okay, so the balloons usually pop, right? They'll pop. Isn't there a way to put a kind of a valve on the balloon to decrease the pressure so they don't pop?
They have that.
And if that were the case, could we just keep going? I mean, I know there's going to be an ultimate limit, but you could keep going to the point to where maybe you could get a picture of the curvature.
The 173,000 will probably be about like the physical limit of buoyancy to payload.
I'm sorry, you were breaking up. Say it again.
I said 173,000 probably getting pretty close to the limit you go with buoyancy and payload.
The payload itself. Yeah, you're right. Sorry.
Yeah, at some point it's just going to reach an equilibrium, just sort of bomb.
Maybe if you heat it a little, you can go a little bit higher, but not much.
Think that will be enough to get a curvature image of the Earth?
Get a curvature image of the Earth just sitting on a mountaintop.
I understand, Zanuck, but I'm speaking on in a different way.
One that you can obviously see with eyeballs without the aid of
just eyeball it.
Straight edge.
No, what I'm talking about is effective curvature. If you want to see actual curvature, you're going to go pretty damn high. And you got to have how you got to take a picture of it with what lens will show curvature.
Yeah, no lens is acceptable because it always has the error that women will say all lenses have error.
That's right.
They never want to go into what those errors are. They all have error.
Refracting through the lens. Run from the data once you provide that PDF file from Leica showing that error of the lenses measured. So let's just ignore what Lemon says and go with the actual science of it.
It's funny how all the errors seem to lead to the same result. What a coincidence!
The same flat Earth. That's right.
You think
you're complaining that the errors show curvature, dummy.
Once you correct for the fake curvature, you have a flat land.
Well, they have a correction. They have lens corrections for every lens out there.
Lim, for all of the ways that we measure the data, you're either going to say that the error, the data, the resulting data shows curvature. You're going to say that's due to error. All I'm saying is you've got all these divergent methods to measure data. What a coincidence that they all seem to show curvature. Just like yesterday, I said, what a coincidence that the 15 degrees per hour of the star rotation matches
the rotation of the ether.
No, my friend. You've got the device, the gyro, 15 degrees per hour drift. There's no ether that can explain that and the stars.
Space is a solid viscous thing connecting all of this stuff together under the dome. As the sun, moon, and stars move, they drag space with it, the ether. That is the drift that you're getting in the gyro.
You would be able to weigh it if it was a solid.
It's solid enough to influence the route of light, slowing it down in the interferometer.
Where's the liquid ether and the gaseous ether?
Passing in and out of objects. Flowing like a fluid.
If only you had evidence for your claims. We
have indirect evidence. But
evidence when you can just make shit up?
Makes you guys too biased to interpret it outside of your paradigm.
Oh, it's 3:00. That's why you're here. It's your shift. You're here from 3 to 7.
Sorry, Brenda, you were saying?
You just make shit up.
You make stuff up for your atheist materialist paradigm. I'm not going to worship the New World Order.
I reason from basic facts. You just make shit up.
No such thing as a paradigm neutral observation. Your paradigm materialist atheism needs to be examined to see if it's giving you a biased interpretation or an adequate one. It appears that the gyro precession can be explained under a flat and domed, still motionless, biblically created Earth.
Yeah,
go ahead.
Sounds like biased, though, Lemon. Sounds like we're biased to interpret this from biblical standpoint.
So we need to see which bias, if any, is closer to reality.
You can do that all the time, Lemon. Why don't you just do it?
Well, the way we decide if something is close to reality is by doing an experiment and making predictions.
That is true.
Yes. And so we have actually done experiments, and we can predict within 12 decimal points. You can't do an experiment. You don't know what the scientific method is, and you can't make predictions.
Take out the bias of the WSGS84 model. Take out the curving lenses that refract and collimate the image as it goes through the lens, and just go with, say, a laser as it travels over the land. Is it hitting a hump of Earth curvature or not?
The WGS model is a measurement limit. It's not biased or built out of anything. It's a measurement.
Built off of globe assumptions, viciously circular logic if you dare to use it to try to prove or disprove the globe.
Okay, so can you show us how this was assembled in the WGS84? How it was assembled on assumption rather than on measurement? Can you demonstrate?
An ellipsoid assumption. That's a globe. Is it not a rather an oblong globe-like figure?
No, don't just say something.
The WSGS84 whatever the hell model has an ellipsoid geoid oblong sphere as its base assumption.
Outcome. And no, but how does the information wind up as this ellipsoid? How do the measurements wind up as this ellipsoid? Show me the assumption involved in assembling the information to create the ellipsoid. Show it.
If you're trying to pretend not to be biased, take out the model that has an ellipsoid geoid, a curved spherical object out of the equation, and just go with the way that a laser travels.
Right, so you can't do it, can you? You're just going to sit there.
And you can't get rid of your WSGS84 bias, can't you?
To do it. I'm trying to wait for you to finish. But you don't do the same for me. I don't know why I'm doing it. Not even sure why I'm talking to you when you're not even answering my questions. You're doing your damnedest to.
You're boring me, Curved. I'm sorry. I got to get down to business.
Well, then get back to your glory hole, then. Okay? Don't let me keep you, sugar.
All right.
He said, "All right."
Not going to answer fucking questions. Don't engage in the fucking conversation.
He's in the glory hole right now. He can't respond.
Okay, since this is done,
me when people make it personal. I need information. I need facts. I don't need a whole lot of drama.
You reject the facts that do not go along with what you already believe.
You reject the facts that don't go with your materialistic, atheistic, man-centered, fake, science.
Stop making shit up.
No, we don't. No, we don't. Go ahead and show me a fact, and let's see what happens. Show me a fact that goes against all that said. That goes against all that BS you just said, and let's see if I will just reject it because it goes against my atheistic blah, 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 blah.
Everybody has a bias. You just have to acknowledge it, remove the stuff that encourages the bias, and just remains past your bias. Your WSGS84 ellipsoid thing is part of what must be proved in this model, curved or flat, so take it out and just go with a laser. Remove the bias.
Give me a fact.
That's Lemon Bird's debate tactic. If someone says something, he just dismisses it as being biased or not following his bullshit paradigm, which is the only right paradigm according to him.
How is the WGS? How is the WGS biased, Lemon?
It's got a curved shape. That's part of what we're trying to establish in this discussion. Therefore, for you guys not to be biased yourselves, take it out of the freaking equation.
No, but what's the bias? I don't get it. What's the bias?
It's a curved shape. We're trying to establish the shape, flat or round.
No. The WGS isn't trying to establish the shape of the Earth.
It's built off of a curved ellipsoid. That's biased towards your side. To get rid of the bias, get rid of the WSGS-84 model and go with the laser traveling over the land.
It's not a bias because the WGS isn't trying to prove that the Earth is whatever shape it is. It isn't trying to do that.
It already goes off of the curved land assumption, which is what we're trying to establish. Using any of that stuff is circular.
No, the WGS doesn't go off of assumptions. It goes off of measurements.
No. Nobody's been to the center of the Earth and back. Nobody's gone from one side of the Earth to the other. This is an assumption of globularity without anything to back up its assumptions.
It's based on measurements. The elliptical eccentricity, which is the degree that an ellipsoid deviates from perfect circle. That's eccentricity. That is a measurement. It's not an assumption.
It's a measurement that's poorly interpreted because of curving lenses and heliocentric bias and a poor understanding of perspective over a flat plane. So we're going to need a laser traveling over the land, hitting the hump, or going straight over the hump, hitting the target like it's flat land.
Larry's happy with that.
Then it would be pointing further down than the horizon. You don't even understand how the curvature model works.
You need to understand how to interpret your measurements properly. There is no curvature of the Earth, only curvature of the lens, and poorly understood perspective in NASA's line CGI.
Yourself and going on a run on. You didn't even hear what I said. You're speaking of a hump. That's not how a curved sphere works. There's no hump.
There would be a hump over a ball of Earth.
No, there would not be. That's not how it works.
Really?
Yes, really. Why don't you get your...
So what would you call the Earth curvature that's in the way of you and something over long distances that's far away? The hump? What would you call that?
You would be...
See, this is why you just frustrate the crap out of globe earthers. You get stuck on semantics all freaking day when you know full well there's a hump in the way. You just waste time.
That's not a hump.
So I prefer to just power past your BS. You curved in other people. Just power past your BS. You're full of crap.
Hump in the way. That's your mistake, Lemon. You think there is, he won't listen to us explain how there's not.
Hey, Lemon. Does a basketball have a hump?
If you're standing on it and viewing something over the basketball, yes.
No, that's not a hump. That's not a hump.
It's just a bad.
And what would you use to describe it?
I would just call it curvature. That's what I would call it. It's curvature.
Curvature is 3 syllables versus a hump, which is 1.
A hump
You're making communication less possible with more syllables when it just basically is a hump. It's a hump.
A hump goes up and then down, and that does not happen on the globe. There's no going up part. It just goes down from your feet. So wherever you're standing on a globe, it will always go down from there. It will never go up and then down. In order to get a hump, you need to go up and then down.
But it would go up and down relative to your feet. If you took a straight line straight from your feet to the feet of what you're observing over long distances, that would be a straight line, and there would be a hump curving up from that line.
But it's weird to call it a hump, though, because from our perspective, there's no hump. It doesn't. The ground never goes up from our perspective.
Right. There's no hump because the land is flat and level.
No, it doesn't go up, though, is the point.
Lemon, the only way you would have... Sorry, go ahead.
Lemon, if I'm an ant on a basketball, the ground beneath my feet curves away in every direction. There are no humps.
But there would be a hump from your feet to the feet of what you're observing, and then the curved land would arch over that straight line. That's the hump.
No. It would curve in every direction.
But
what would happen is the curve.
What straight line is he referring to? A cord?
The cord from your feet to the feet of the object. Yes, the cord.
Beyond the body.
So there would be a cord there, and then the curved arc would be the hump over that.
Okay, there is a sagittal. There is a sagittal at the center of the cord. So what?
So where is this hump? We see flat level land, no hump in the way. When we have a 2-foot laser off the ground or whatever, trying to hit a 2-foot target over long distances, there's no hump in the way.
The hump is in your base. If you're viewing along the direction of the cord, parallel to the cord, you're gonna see hump. If you're parallel to the cord.
Yeah, there will be a sagittal between me and any other object on the globe Earth, especially if that object is over the curve.
I'm not picking on you, Lemon, but your orientation is off here.
Well, I'm speaking with, my mates at the glory hole, and they don't see how, this Earth could be curved when all we see is flat level land.
Orientation I was referring to, Lemon.
Oh.
But at least you got the double entendre. Good on you for that. But anyway, seriously, if your line of sight is parallel to the cord, you're looking at effectively hump land in the way. You're looking down, dude. The cord is not parallel to your horizontal from your viewing position. You know that.
Well, you have this cord under your feet, and then that's going to give you a height of the hump. You have to shoot something over that height to get over the hump. Brenda, you were saying?
Well, there's no hump
on the horizon. Draw out a cord that's parallel to the tangent.
There we go.
I invite you. I beg of you. Draw the parallel. Draw the tangent parallel to the cord.
All right. But if you draw it parallel to the tangent, it would go off into the air over the head of the thing that you're aiming for. You have to draw a cord through the circle, which means that you have to go at the bottom of the hump, or something parallel to that if you're going to hit the target without hitting the hump.
Lemon, this is real easy. And curve, you can blow me away if I'm wrong. I do not believe that the cord and the tangent line are parallel from the same starting location.
They are not. The tangent is 90 degrees to the diameter of the circle. The cord is not. The cord's at a deeper angle.
Beach, revoke Platin's speaker role, please.
It's fine. What he said was correct.
What?
What Flat just said is correct, that the tangent and the cord are not going to be parallel.
Yeah, you could prove it by cutting a circle into very small pie slices. When you cut the circle into small pie slices, 360 degrees around the circle, you're going to get very thin pie slices with a little tiny angle coming from the center that is going to approach zero and be very small.
You keep talking all the time. I think Curve was going to respond.
Okay. Take the point where your feet are at the surface of the Earth, okay, that part of the sphere. Now, from your feet, you're going to draw a tangent, and then you're going to draw a cord in the same direction, to some distance away, to make it 10 miles away. Okay, your cord's going to be 10 miles long.
Oh, I see what you're saying. That's what you're saying. It's different
not parallel.
Well, I thought.
Yeah, but the cord's going to come down at a deeper angle.
Lemon, just let other people talk for a little bit. I thought you guys were talking about the tangent taken at the point where your feet are touching the sphere, but you're not. You're saying taking the tangent at the point where the sagitta of the core.
No. The same point of origin, where it's tangential at the tangent point, and draw your cord from that point forward in the same direction as the tangent line.
Well, if you take a tangent at your feet, you're taking something that's perpendicular to gravity. Yeah.
Correct. And the cord will not be perpendicular.
That's right. So they're not parallel.
They're not parallel. That's what I said.
Okay, that's what Flatten said too.
So And it's going to be a pump.
Hold on, Lemon. No, I heard him say they're not, and then I don't know, Flatten, what did you say? I thought you said they're not parallel.
Well, this is the part where I just power past what Curve's saying because he's not helping us to establish anything.
Hold on, Lemon. I'm talking.
The cord would go straight through the earth.
Lemon.
That is all.
I'm in the middle of discussing something with him. Can you just have some patience? We're not going to take the mic forever. Just like be reasonable. So did I mishear Platten? Is that what happened?
Well, I don't know. Only Platten can confirm it, but he's not speaking up. So
he must have stepped away.
He was.
All right. Well, I'll ask him. We can check to see if I was right or wrong. But yeah, we're in agreement. What you're saying is